Over to you, sir.
Thank you very much, and very good morning to everyone who is participating in this online program, and some students are sitting offline also. You all know that this is on the eve of National Mathematics Day, which is normally celebrated on the birthday of the great mathematician of India, Ramanujan. So, friends, today we have a very eminent person, Dr. Mahesh Sharma, who is a person of Indian origin but is in UK, and is working in the area of mathematics. He has started working for numeracy skills in young learners at very early stage in preschools and grade 1 and grade 2. So he is working in collaboration with one of the organizations here in India also. His profile is available on the website, so you can go through that profile. I am not going to have more on that. Very good morning, Dr. Mahesh.
Good morning to you, sir.
This really is a very odd time for you.
Yes, I will sleep tomorrow.
Present in this section because you it is around 4 a.m. at your place.
11,
Am I right?
11 p.m. of the previous night. 11 p.m.
Oh,
on Tuesday night.
okay. Okay. So, as you know that this is the National Mathematics Conference seminar which we normally do every year. This is the 10th in the row, and we used to have different papers being presented. Probably you may have also attended some of the sessions wherein you may have seen some researchers and people who are working in the area of school mathematics, like say teachers and teacher educators, may have presented. They have presented their papers, and you have seen. Today, my dear participants, Dr. Mahesh is going to talk to you on development of early numeracy skills, and this is the high time when we have started talking about the numeracy skills in young learners, because national education policy has pertinently highlighted the importance of foundational literacy and numeracy, giving importance to the early childhood care and education ECCE. So keeping that in view, now everyone has tuned to working in this area. Government of India has launched a mission known as Nipun Bharat, which is particularly for development of reading and numeracy skills among learners of age 3 years to age 8 years. So, without being more in between you and Dr. Mahesh, I will request Dr. Mahesh to please start delivering his lecture. And as usual, friends, I will request all of you to please keep on writing your questions and queries whenever you have any, and then in the end of Dr. Mahesh's presentation, we will be giving you time to ask your questions. You may also send your questions in the chat messages. So, Dr. Mahesh, it is over to you now.
Thank you very much, Dr. Rajput. I would like to present two scenarios in front of you. One is, I am very much interested in history, but I look at history from mathematics development point of view. In other words, what did history contribute to the development, what did mathematics contribute to the development of a country, a nation? When you look at the long history, up to 8th century, the focus of mathematics was either in China or in India. After 8th century, there was a hiatus, and we actually started looking the focus shifting from Asia to Europe. As a matter of fact, in the 14th century, the beginning of Renaissance in Europe, the focus was in southern Italy, Sicily as known, and Spain. When you look at the history of development of countries, you will find that countries have dominated the world where mathematics were at the pinnacle. And when you look at each century, you will find that the focus of mathematics in the country was contributing to the development of all aspects of that country. 14th century, it was Spain. And Spain was the biggest power at that time. 15th century was Portugal. And as you know, in 15th century, they wanted to invent or discover India, and by mistake only they end up in United States, America as it was called. 16th century and 17th century, the focus was in Europe, Germany, Dutch Netherlands, France, and British Islands. Those 2 centuries have a great history in mathematics development. In 18th and 19th century, it was British and the French. And as we moved to the 20th century, half the century was British century when the empire was all over the world. And then it began the century of the United States. That's what they thought. But as you can see, United States ascendance is from the end of the Second World War, and now when we look at the distribution of scientific papers, research papers, 1/3 of the papers are from the United States, which used to be 70% in the later 20th century. Almost 30% of the papers, research papers in mathematics and sciences, are from Europe, and another 30% are all over the world. You can see the shift of the focus of the research papers. I'm saying this, that at the beginning of the 21st century, if we can grab it, it could be the century of Asia, and the focus could be either in India or in China. And as we see the development and production of research papers, particularly in mathematics, it is oscillating between India and China. Now, to gather that steam, to reach that point, there has to be an emphasis on the early mathematics. I'm also an evaluator of learning problems in mathematics. So when I see children who are having difficulty learning, on evaluation I find that most of the time, difficulty is in the early numeracy. I want to give a parallel between reading skills and numeracy skills. I will naturally compare English language to numeracy, but it can be generalized to other languages also. Hindi has an advantage because it's a transparent language, and English is called opaque language. So I'm going to compare opaque language of English and numeracy. And numeracy also has some opacity, and therefore the comparison is valid. To be fluent reader with comprehension, we need 5 things. A child must know his alphabets. He must have a good sight vocabulary. He must have good phonemic awareness. And by the help of sight vocabulary and phonemic awareness, the child acquires what we call as word attack skills. Then we need a 5th, an important component, and that component is a knowledgeable, sympathetic adult who helps that child to be fluent in the word attack skills, particularly the sight words, phonemic awareness, and breaking, chunking and blending of a word. With these 5 things, a child acquires fluency and comprehension in the language. And once the fluency and comprehension is there, now reading is not the focus. The reading becomes the means of learning. Up to 3rd grade, the objective is to acquire, to learn reading skills. And after 3rd grade, the objective becomes reading to learn other things, whether it's mathematics or history or social sciences or sciences. And the skill has been acquired, and the child is ready to learn anything. I find a similar situation happens in early numeracy. There are 5 things needed in early numeracy. And before I set up those 5 early things, I want you to imagine a scenario. There's a group of 5 or 6 people. It's early human development, early human survival times. They are still in the hunting period. And at that time, people traveled, hunted, explored in groups of 5 or 6, close people. I'm saying just 5 or 6 because it's a very significant number. Now these 5, 6 people, why they are going in groups of 5 or 6? Somebody is looking in front, 2 people are looking on the sides, somebody is aware of the back, and there's somebody who is also coordinating these 5 or 6 people's actions. And they encounter a group of predators. Now, they have a good idea of their group, the size of their group, how many are there, not by count, but by an estimate, by knowing personally each one of them. Now they compare this predator's group with their group. If this number is small, they will fight with them. If the number is large, then they will see whether our resources are better than theirs or ours are stronger, and they fight. But suppose the other group, the predator's group, is larger, then they make a decision that we should run away so that they can save. So at that time, 3 skills are developing. One is the ability to estimate the size of a group, which is known as subitizing. They are trying to compare that group with their group, so they are also learning one-to-one correspondence. They are also seeing very large and very small. There is another thing happening, and that is spatial sense. Should we run away to the left, or to the right, or in the back, or on the sideways? So they are also acquiring what we call as the spatial sense. And then, at the same time, a third skill is developing, called the language. The person in charge also has to convey to the group what decision they are going to make. So at that early time, for survival, for evolution, 3 skills are beginning to develop. The rudimentary language, rudimentary number sense, and rudimentary spatial sense. The beginning of innate number sense, subitizing. Children are born with innate ability to recognize a collection up to about 5 or 6. And that 5 or 6 is not random, it is because that was the maximum size of group. Without disturbing the surroundings, they could travel, they could go, they could run. This subitizing forms the basis of number concept. But when the child is learning subitizing, culture's role is to optimize. All of you and the audience, I'm talking to the students now, you have never seen the beginning of the IBM computer. In 1985, I have a good fortune of getting the first computer. In 1967, when I came to United States at MIT, IBM company gave 4 computers, PDP-11. And that PDP-11 could do only 4 things: addition, subtraction, multiplication, division. And there used to be a line to use that computer. I'm giving the example of that when the IBM had a personal computer, you had to reformat it. In other words, before you put the diskette, you have to formulate it. And then and only then you could save on it. A human mind is just like that. The child has innate ability of subitizing, but it is formulated, it becomes apparent only when there are experiences provided by the culture. So in the first few years, the child is realizing this subitizing ability by exploring, by interacting with his surroundings, with his habitat. And the culture provides the language. So after 2 or 3, age 2 or 3, around 4, the language comes into play. And that subitizing can be extended to 10 now. And I call that as visual clustering. Why 10? Because from the very beginning, human beings have been interested in 10, because it's 10 fingers. So subitizing is only up to 5 or 6 elements. And since our base 10 is based on 10, we need to extend that subitizing to recognizing a cluster of 10 objects. For last 40 years, I've been working with the children to see how do we extend this subitizing to visual clustering so that the base 10 becomes accessible to children. I'll take a little personal note here. When I was a young professor at one of the universities in Boston area, one of the associations in Boston area, the name of the association was an association of mentally retarded children, helping mentally retarded children learn reading and numeracy. And they requested me whether I could teach a group of children, age 8 to 14, IQ 48 to 62, whether I could teach them numeracy, number concept, so that they can have life skills. Now, being young, you are arrogant and you do not know your limitations, and therefore you take risks. So I volunteered, yes, I will be able to teach these children. Now that arrogance paid up in the sense that 6 months I had no success at all. One day those children can identify 4 or 5 objects and call that as 5. Second day that would be the same thing, would be 6 or 7 or 8 or 3. So I was driving back from that experience, 6 months of unsuccessful experience, and I was deciding either I'm going to discontinue this experience, this volunteer work, or I must find a way of reaching these children. I come from a small village in Rajasthan, and in the summer, long summers, there was nothing else to do but to play cards, playing cards. So we used to play several hours of playing cards. As a matter of fact, nobody taught us in school in first and second grade addition and subtraction. We already knew that because of the playing cards. We have identified clusters, we have identified how to combine them, and the games we were playing, we had to find out the sum and differences of those. So the early learning of mathematics took place by playing cards. So I decided I'm going to buy a set of playing cards, a deck of playing cards, and I'll work with these children. Because if I can learn, they can learn too. If my friends could learn, they could learn too. Again, arrogance on my part. So I started working with them. Up to 5 or 6, they did not have much problem. But they would look at the corner of the card where the number is written. So I cut the corners so that they will not be looking at the numbers. So I had these cards, which the corners are cut. Now they started focusing on clusters. And they started looking at the relationships. And within 4 or 5 weeks, they had recognized the 10 numbers by sight. They could even say that 10 is 1 more than 9, because they could compare the 9 card and the 10 card. They could even see that 10 was made up of 5 and 5. They could even see that 10 was made up of 8 and 2. The problem was, they still did not know the number relationship that well. So I started reformulating those cards so that they could see the relationship of numbers. I had read an article. As a matter of fact, I had a good fortune of spending a month in 1968 with Piaget, and there I found that he was a master of questioning children. He was a great interviewer. So I started using the Piagetian approach to asking children, and then I found that when I showed them a 2, without counting, with one or two exposures. They say that's a 2. If I showed them this, with one or two counting, they will say that's 4. And then they will say 2 and 2 is 4. 3 and 1 is 4. That means they begin to decompose, recompose these clusters. Decomposition, recomposition is parallel to phonemic awareness in English language reading. English reading. That means in phonemic awareness, you take a word and cut it, break it into phonemes, and then you blend them and you say the word. This process of breaking a word and then putting it together, those sounds, phonemic sounds, and then learning the word, was the key for my children I was working with to learn what I started calling them as sight facts. So what is sight words in reading? Sight facts is in numeracy. In sight facts, the children are doing several things. They are doing the innate behavior articulated, and they are extending that innate behavior to learn number relationships. So the 5 things in numeracy, fundamental in numeracy, are the child must know the 10 elements of the alphabet, that means 10 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And once the child knows these 10 alphabets of mathematics, then the child learns the sight facts. That means 4 is made up of 2 and 2, 1 and 3, 3 and 1. So 4 has 3 sight facts related to that. The problem I found that the usual cards were not really conducive to develop the sight facts of numbers larger than 5. They were not conducive to that. So I redesigned some cards. So if you look at this card here, one can see 8 and 1 is 9. One can see 7 and 2 is 9. One can see 6 and 3 is 9. One can see. So on each card, by the way, that is not my sound. That is not my yes, if you can keep that off, sir, that will be good. So as you can see on this number 9, this cluster of 9, they are able to identify subclusters, and they are able to recompose the subclusters, and therefore they acquire the sight facts of 9. So the first is recognizing the clusters for 10 numbers, then decomposing, recomposing of those clusters, and then learning those sight facts. That gives the children what we call as number attack skills. When a child has acquired number attack skills, then the arithmetic facts become easier to learn. Therefore, these 5 elements of those number sense are the key elements. It looks like there is a question from the audience, and I don't mind taking a question in the middle, and it might be a planted question in doubt. Okay, sir.
Sir, I want to ask you, when you showed that 4 card, you said that you were going to how is it?
Our MS students, please stay back. MS students.
Is there a difference?
9th and 11th.
Yes, there is a major difference. Nobody learns to read by focusing on each letter. The fluency does not come by focusing on letters. Fluency comes by focusing on phonemes. That means the units of sound. And it also comes by sight. So when we derive 1 plus 1 is 2 and 1 plus 1 is 2 and then 2 and 2 is 4 by counting, you are focusing on each number, and therefore it takes longer to arrive at fluency. And when it comes to larger numbers, it becomes fleeting. And therefore there's a difference between side effects and also what we call as number bond, or addition of numbers. So the 5 things I pointed out earlier: knowing the alphabet of mathematics, knowing the 45 side effects of numbers, having the decomposition, recomposition, and then combining the side effects and decomposition, recomposition, children learn the facts, arithmetic facts. And when the arithmetic facts are mastered, then we go to other higher order mathematical concepts. So the fundamental to numeracy is, first element is number concept. Now these cards or any of the counting materials are discrete elements. Each one of these objects are discrete, and therefore children remain on counting for a very long time. And that is one of the problems. As long as the child is on a counting system, the child will take longer to automatize the facts, to have the fluency of facts. So then you convert these discrete elements to continuous elements. And the continuous elements means you associate some kind of color in length with the number. So these are called Cuisinaire rods. These were designed by a Belgian mathematician to teach children number concept. So I asked the child, could you please cover these by these unit cubes? Say yes. Could you please put them next to each other? And could you see which rod will be as long as this one? And the child finds out with some experience that it is 3. Now it has become a unit. So I said 3 or 4, and that counting is gone. And therefore the child now can see 3 and 4. I wonder which number might fit, and let me see, and I find that this 7 works. So 3 plus 4 is 7, 4 plus 3 is 7, 7 is 3 plus 4, 7 is 4 plus 3, and so on. But more importantly, if this is 1, then this is 3 plus 4 is 7. What if I call this as 10? Then all of a sudden that becomes 30 plus 40 equals 70. 40 plus 30 equals 70. 70 equals 30 plus 40. In other words, now we can extend it. I can also call this as 100. And then it will be 300 plus 400 is 700. I can also call this as 1/10. And then 3/10 and 4/10 will be 7/10. I can also call this as 1x. Then 3x plus 4x will be 7x. The idea is that number is the foundations of all numeracy. And as I said in the beginning, when I'm evaluating children, most of the time, children who have difficulty in mathematics learning, or those who have math anxiety in mathematics, most of them have not mastered number, and therefore they have not mastered addition facts, subtraction facts, multiplication facts, division facts. So that's the second part of that. Before I come to that part, how to teach children the concepts of these arithmetic facts, I want to bring a second element in the numeracy, and that is every mathematical concept has 3 components. Linguistic, that means the language of that concept, linguistic component. Second is called conceptual component, that means the conceptual schema behind that mathematical idea, conceptual model behind that mathematical idea. And the third is called a procedural component. Mathematics idea is learned when we have integrated linguistic, conceptual, and procedural. Now, let me take an example of that. Suppose I look at this problem and I ask you, or ask a child, tell me what does this mean to you? Many children will say, oh, that's 12. I say, no, I did not ask what is the value of this one is. I'm asking you, what does this symbol mean to you? What do you mean what this symbol means to me? It's multiplication. So what does it mean to you? And after some thought, if the child has a concept, he might say, oh, it is 3 repeated 4 times. Then I say, what do you mean by that? Oh, it means that I add 3 and 3 and 3 and 3. I say, how will you find it? Oh, well, I have 3. Here is a 3. Here is a 3. Here is another 3. And here is another 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12. How did you arrive at the answer? I counted 1, 2, 3, 4, 5, 6. So I have introduced the concept of multiplication, but cognitively, content level, the child is still at the kindergarten level or pre-kindergarten level, because he arrived at multiplication by counting. In other words, the conceptual schema is not commensurate with the mathematical idea, and therefore there is incongruence between the concept of multiplication and the method by which the child has arrived at the answer. So suppose I say, all right, you are right, it is 3 plus 3 plus 3. Suppose we take that 3 you identified earlier, and we say here is 3, here is 3, here is 3, and here is 3. And write to the child, oh, I know 3 and 3 is 6. I know this 3 and 3 is 6. I happen to know 6 plus 6 is also 12. Now the child has gone from the counting level to using the arithmetic facts. Now what do I mean by that? You see, counting is the first level of numeracy. As I said, in that savannah, when they are hunting, they are already doing that one-to-one correspondence. They are not counting 1, 2, 3, 4, 5, but there is a one-to-one correspondence going on. Counting, when abstracted, you get a number. When children come to kindergarten or pre-kindergarten in India, and you ask them, show me 3, and they will say 1, 2, 3. About 2 months later, you ask them, show me 3, and they say 3. In other words, they have integrated those 1, 2, 3 into a cluster. That is a growth. That's a development. That's a developmental milestone. That means they have abstracted counting into numbers. And little later, when I put 3 and 3 together, and they say 6, then we have abstracted at the next level called addition level. And when we take this 3 and 3 and 3 and 3, we have abstracted it further. And now this is the third level of abstraction called multiplication. Till the child is treating multiplication at the abstraction of addition, the child is really not aware of multiplication. He can give you 3 times 4 is 12, but that does not mean he knows what the purpose of that is, how do I apply it, and how do I extend it. For example, if I ask the child, is 3 plus 3 plus 3 plus 3 more than 10 or less than 10? And the child might say, let me count, and I'll tell you what it is. But suppose we have converted that count into a linear relationship or continuous model, and the child will say the innate thing, it looks like more than 10. If it is more than 10, let's check it out. And I put the 10 here, and the child says, oh, I added 3, I cut this one from 3, gave it to 9, it became 10, and as I can see, there is a 2. And now 3 times 4 is 12. When I reach that level, I'm at that third level of abstraction. Otherwise, I'm seeing that multiplication as the starting point. This reach of the abstraction is an essential element for children to prepare for higher mathematics. If they are still at the counting level, or if they have memorized it. When I was in my village, we memorized tables up to 40. But somebody asked 39 times 39 and I could give the answer like that. But what does it mean? I don't know. I was in a fifth grade class the other day, and I asked a student, what is 8 times 7? And he rightly said, 56, sir. I said, how many groups of 8 are in 56? I said, no clue. How come? Well, I memorized by the cards. When we memorize something, we are not learning the concept. We are putting that concept or the answer in one place in the brain. And that place is the same place where children put habits, or anybody puts habits. When we form a habit, it is placed in the brain called basal ganglia. Basal ganglia. And there, the information is placed as a unit, as a piece of information. There is no relationship being made. It is actually not in the areas where language is, or where other concepts are, or where the space is. So it does not connect with anything. It remains isolated, just like any habit. So if we are learning the multiplication tables by memorization, yes, we can do lots of things. I'm not saying it's bad, but you are not actually learning the relationship, the connections, the extensions, and abstractions of high level, as we see in a moment. Then I say, can you tell me any other way I can read it? You told me that multiplication is repeated addition. Can it be anything? When the child says repeated addition, that child has a linguistic component. And when the child says 3 and 3 and 3 added together, the child has a conceptual component. And when he gives me the answer that it is 12, if he did the counting, it's a lower level of procedure. If the child says 6 plus 6 is 12, that's another level of procedure. And the child says 3 plus 3 and I take 1 from the 3, make it 10, 10 and 2 is 12. That is another level of procedure. So procedures exist at 6 levels of knowing. The first level of knowing a procedure is called intuitive level of knowing. Intuitive level of knowing means I know something about it and I'm able to access it by the help of what I already know. Second level of knowing a concept is called concrete level of knowing. I just arrived at the answer by the concrete level, by the counting of things or seeing those green rods. The third level of knowing a mathematical idea or a procedure is called pictorial representation, or knowing that by the pictures or the diagrams. And fourth is called abstract level of knowing. That means now I can deal with 3 plus 3 plus 3 plus 3 and say it's 12. 6 plus 6 is 12. Fifth level of knowing a mathematical idea is called applications level of knowing. That means now I can apply that concept. I can solve problems. As a matter of fact, applications are of 3 types. And those 3 types are, first one is called intra-mathematical application. Intra-mathematical application means I can use what I know in one part of mathematics to another part of mathematics. That's called intra-mathematical application. I know addition, therefore I can learn multiplication. I know multiplication, therefore I can learn division. I know how to solve linear equations, therefore I can solve a problem in geometry. So that's called intra-mathematical application. The second kind of applications are called interdisciplinary. That means I know some principle in mathematics, And now I can solve a problem in chemistry or in physics or in some other area. There is a concept in comprehensive universities, it happens. An idea in mathematics is discovered or invented. Within 3 years, a physicist will use that mathematical idea to explain some physical phenomenon. And within 3 years, applied physicists will do something with that. That means not only they will explain, but they will come with a representation of that in some form. And within 3 years, some technologist or engineer will apply that for applicability. And 3 or 4 years later, an entrepreneur, innovator will bring it to the street. A country's greatness is dependent on this design spectrum. More mathematical ideas are discovered in a country, that country for future is secure, because mathematics explains physical phenomenon. Physical phenomenon then becomes useful because now we have a method of explaining and harnessing that, and then the entrepreneurs will take place. You can see the examples of that. Many of our countrymen come to UK or Germany or to United States, and they are becoming entrepreneurs, innovators. Why? Because they are now looking at the connections and they have ready access. Most of the innovations take place around the universities in the United States. As a matter of fact, you look at all the great universities and surrounding them are research triangles or technological innovative companies or organizations. So comprehensive universities, the innovation begins with mathematics, goes to physics, chemistry, and other areas. So that is called interdisciplinary applications. And the third kind of applications of mathematics, we call that as extracurricular. That means they, in the 12th year, as I mentioned earlier, they go outside of the curriculum, outside of the university, and therefore they become applications. I remember I came in 67 and 68, moon landing took place. And in moon landing, there was a concept called GPS was used. And about 8-9 years later, it started coming in the cars. What does that mean? At one point, it was a research thing. And only 10-12 years later, it was on the street. And today, as you can see, there's nothing which does not have a chicken on it. John Boole, in the early 40s, wrote a 3/4 of a page article called Boolean Algebra. Let me see an algebra using only two symbols, 0 and 1. And he developed the addition table and multiplication table. And at the end of the article, he wrote, for my own entertainment, I have written this article. I know there won't be anything usable from this article of playing with zeros and ones. And as you know, 3 years later, 4 years later, von Neumann at Princeton University gave a prototype of a calculating machine based on John Boole's idea of zeros and ones. And today, every one of you knows that without the Boolean algebra, there is no computer. There is no nothing for that matter. So the ideas are developed in mathematics. They give rise to these big ideas. But all of those ideas are really dependent on the early mathematics. Children's solid foundations of number, numeracy. Let me continue. So I ask a child, why am I going to the second definition of multiplication? As a mathematics teacher, as an elementary school teacher, as a middle school teacher, you and I have two goals. One is to help children acquire content of mathematics. That means the language, the concepts and procedures of mathematics. But we also have a second goal. And the second goal is to make children better learners. And better learners means they have good executive function skills. What do I mean by executive function skills? There are 4 skills which are indicative of good preparation for learning. The first one is working memory. That means, am I able to hold information in the mind's eye? Am I able to manipulate that information in the mind's eye? Anything which we can manipulate in the mind's eye goes to long-term memory. The second element of executive function is focus and attention. Am I able to focus my attention into the task? Third element of being a good learner is organization. That means, can I organize my thoughts? Can I organize my materials? Can I organize my activities? Can I organize the language associated with that idea? Am I able to task analysis to the task? Can I analyze the task? Can I make into components and relate them? And the fourth one of executive function component is flexibility of thought. Children who have flexibility of thought, they are better prepared for mathematics and STEM fields. And flexibility of thought cannot take place if we do not give children multiple models. But the multiple models must be transparent. Transparent means the concept and the modeling must be congruent so that I can see the relationship of that. So as a teacher, as an instructor, my goal is to do two things with the children. Increase their content and at the same time help them to become better learners. Now these two things cannot happen unless we actually look at mathematics not as an isolated activity, but we look at each mathematical idea as a trajectory of a mathematical idea. For example, 3 times 4 as repeated addition is a dead-end street. For example, if I come to 1/2 times 1/3, how do I use this definition of multiplication of repeated addition to 1/2 times 1/3? What do I repeat how many times? And many teachers, they don't know how to apply that. So what do? Just multiply 1 times 1 is 1 and 2 times 3 is 6. There's no idea. And therefore the first misconception begins. And that the first misconception a child faces is that when I was multiplying numbers before, the product was getting larger. And now, all of a sudden, the product is getting smaller. What is happening? And they begin to doubt their ability. They begin to doubt their outcome. And therefore, they begin to dislike mathematics. So our methods must be such that the concept can be extended. So multiplication begins with repeated addition, but it does not end with repeated addition. So therefore, I ask the child, can you tell me another way of seeing this 3 times 4? And after some goading, the child said, oh yeah, it is also 3 groups of 4. Well, what do you mean by 3 groups of 4? Oh, that's the same thing. I have 4, I have 4, and I have 4. And I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12. Again, if I use this, as I used earlier, the child is at a lower level in procedure. But suppose I change. Well, can you use this rod? What will you call this rod? Oh, I will call this 4 because it's the same length. So now I have a 4, I have a 4, and I have another 4. And I find that, oh, I know, 4 plus 4 is 8. And I take 2 from here, give it to 8, that became 10, and 10 and 2 is 12. Now you notice that I'm always making 10. Making 10 is a fundamental skill in numeracy. I have found the children who are not able to make 10 fluently, they take much longer in mastering arithmetic facts, addition, subtraction, multiplication, division. So after sight facts, making 10 and teens numbers are the foundation skills. So knowing 45 facts, making 10 and making teens numbers, they become the basis of all the arithmetic facts later. But at the same time, the child is seeing also the repeated addition and groups of, it gives rise to the same thing. That means I can see this multiplication either as repeated addition or I can see this groups of. If I press the child a little bit more, particularly elementary teachers, and they will say, well, actually I have another definition of multiplication, and that is 3 by 4 array. And I ask, what does that mean? That means 3 rows and each row has 4 elements in it, which I arranged right here. We have 3 rows and there are 4 elements in it. Now please look at it. Up to this point, our multiplication was a linear expression, a line. Now it has become a 2-dimensional concept. And when it becomes a 2-dimensional concept, qualitatively and cognitively, it is at a higher level. As a matter of fact, now we begin to see relationship of other numbers and the multiplication of other numbers. Only thing is, here there are still discrete elements, and therefore the child is tempted to count these. So how do we take the child from this count to a continuous model? And therefore multiplication becomes the 4th element, which is called area of a 3 by 4 rectangle. And then you can multiply fractions, you can multiply decimals, you can multiply algebraic expressions, you can multiply anything. And therefore, we have seen this now, multiplication as trajectory of a concept, rather than an isolated concept in arithmetic. Unless we do these abstractions and these extensions, the children see mathematics as a compartment like. And that's why very many children do not go beyond 6th grade willingly into mathematics. If we want more children to go to mathematics, they must have arithmetic foundation on strong foundations. In other words, they must have good concept of number sense, and numeracy. And now when we see it, oh, I can see this converted into the area, converted this also into area. And at the same time, I see that if I look at this as 4 repeated 3 times, and I see this 3 repeated 4 times, and if I put them on top of each other, I also see that 3 times 4 is equal to 4 times 3. I begin to see the relationship, that means the properties of operations. As a matter of fact, if I take another step and I look at this rectangle, then I will say, oh, this is 3 by 3 plus 2, 4 plus 2, because the purple is 4. And I can break it in 2 parts. So it has become 3 times 4 plus 3 times 2. And the distributive property of multiplication right away emerges from the area model. So if we want children to have solid foundations of arithmetic, we need to do 3 things. Number 1, we must teach all the 3 components of a mathematical idea: linguistic, conceptual, and procedural. We need to focus on all the 6 levels of knowing mathematics: intuitive, concrete, pictorial, abstract, applications, and communications. Communications means, can you explain what you just did? Can you tell me why did you do that? Can you extend it? Can you relate it? Can you connect it? Third thing, an important part, is the role of a teacher. A teacher has in a classroom 3 roles: didactic, Socratic, and coaching. Didactic means there are certain words, certain terms, certain ideas. They are not accessible to child in the ordinary living particular environment. It is the role of the teacher. There's a lot of research in role of language in mathematics development. Every language has its own characteristics. For example, in English, the words used for number are long. 7, 8, 9, 10, 5. In Chinese, the number names are very short. And therefore, when they are memorizing multiplication tables, they take less time. As a matter of fact, in India, we bypass that by contracting them. Chasatta, Bialis. Well, what did we do? We actually contracted that, and therefore we have converted that fact into a small word. Chasatta Bialis. I mean, I learned that in my village, and that's how my teacher taught. The only problem is, Chasatta Bialis does not really give any concept of multiplication. It's only a nonsense word. It doesn't really have a model behind it. So it's the role of the teacher that the words used in teaching arithmetic, they are properly describing a mathematical operation. For example, when the child says 3 into 12. Now, in America, they say 3 goes into 12. And I tell the children, you know, when I go in my car, I don't do division, I drive it. So, the words used for expressing mathematical ideas must be suggestive of that mathematical idea, rather than a word which does not indicate any relationship of that operation with the language of that idea. So that is the role of a teacher as a didactic teacher. That means you emphasize, you insist on the proper language, appropriate language. The second role of a teacher is Socratic questioning. Socrates, after whom this Socratic questioning has become famous, used to say the child has a lot of language, a lot of ideas, a lot of knowledge already there. The role of the teacher is to bring it out. Actually, in Greek language, the word for teacher and the word for midwife is the same. What does that mean? He used to say a teacher is a midwife. The role of the teacher is to bring that language out by asking enabling questions. Questions that instigate thinking. The questions that help child to connect. The questions that bring suggestions to the thinking. He used to say, and I add to that, teacher is a midwife, and hopefully she helps deliver this knowledge from the child's brain in reality on the paper, hopefully in an organic and easier process rather than a Caesarean operation, which is what many teachers do. That's the experience I had when I was growing in my village, and if you made a mistake, there was a little instrument nearby, and that was used quite often. I have not very good memories of mathematics learning. I have quite negative memories of mathematics learning because of that behavior. So there was no midwifery taking place there. That was actually Caesarean operation taking place in teaching mathematics. The third role of the teacher is what we call as the coaching. Coaching, what's the role of a coach? The role of a coach is to set the standards, show the behaviors which meet the standards, and then help the child to reach those standards. The role of the coach is to do the task analysis, and then master each one of the component tasks, and then help child to put them together. When we have these components in the teaching, there's another element comes into play, and that is the role of instructional materials in teaching. There are 3 kinds of materials. Materials which are effective, efficient, and elegant. Now what do I mean by efficient? See, if I count 5 plus 7, that will take longer than if I say, let's see, 5 plus 7. 7 is a bigger number. How do I make 7 into 10? Oh, I take a 3 from 5, give it to 7, it became 10. And 2 was left in 5, so therefore 12. That's decomposition, recomposition. That is using side facts, and that's using making 10 and the teens numbers. In other words, there are 4 fundamental skills for any fact. That is, do I know my side facts? Do I know how to make 10? Do I know the teens numbers? And do I know decomposition, recomposition? So when there is effective material, effective teaching, and the teacher has good understanding of the content of mathematics, understanding of children, and the use of efficient, effective, elegant materials, more children will be interested in learning mathematics. Otherwise, many more children go away from mathematics, not because they don't have the ability, cognition, they don't have what is needed, the encouragement from the teacher and the proper teaching. I will open for questions, comments, agreements and disagreements for a few minutes, and then we will have questions from Dr. As a matter of fact, Dr. Rajput, if you have questions in the chat, then you can ask me now, and people can ask directly if you want to. But if I can request the technologists there to have the all on a window mode, so I can see their faces and I can recognize their hands, and I'll be more than happy to answer questions or agree or disagree, as the case may be. So let's make it in a classroom rather than an online representation. Okay, Sanjay, you have a question. Your hand was up for a long time.
Sir, you said that when we extend multiplication to these other models, then we can show relationships and extend that from repeated addition or whole number operations to even algebra. Can you actually show a kind of example how you can do that?
Sure, let me take an example. So first I will take an example at a whole number level. So let's say I take 12 times 13. Now notice, if I took the repeated addition, 12 times 13, I'll have to have 12 plus 12 plus 12 plus 12, and I'll grow old by the time I have added all of them or counted all of them. Or even I've had 12 groups of 13, the same thing will happen. But then I have an alternative. 12, isn't that about 10? 13, isn't that about 10? So in other words, my starting point is what? To look for a rectangle which is 10 by 10. So I look for a rectangle which is 10 by 10. So here is 10 times 10. 3 things have happened just doing this one. One is the child already has an estimation of what do I expect as the answer. Second thing is he's building up rather than starting to build. Building up rather than starting to build. I want 12 times 13. That means the first number is the vertical side and the second number is the horizontal side. So how do I make it 12? Well, look at this, has now become 11 times 10. And now if I put this one here, it has become...
Can you put it a little up? Can you put this a little up?
Yeah, you're too demanding, Sanjay. So we have 12 times 10. As a matter of fact, the child said, oh, 12 times 10 is 120. Wonderful, very good. But we want 12 times 13. How do I do it? Oh, so that will be this side. So I take, that is 11, that is 12, that is 13, but it's not a rectangle. So let's see, that is a 12, that is a 12, and that is a 13, and my answer is where? In the area of this rectangle. So how much is that area? 100, 20, 30, and 6. My answer is 156. But very importantly, look at the 3 is the bottom right-hand corner of this arrangement. Look at that 3 is in the bottom right-hand corner of that arrangement. So look at this rectangle. 2 times 3. I have 2 times 3. 6. Look at this rectangle. 10 times 3. 30. And what's the most efficient way of writing 30? I write 3 in the tens place. Look at this. 2 times 10. 2 times 10. Do I have that here? Yes, 2 times 10. And 20. What's the most efficient way of writing 20? 2 or 20? Well, I cannot write in the first row because that's the hundreds place. So I open a new account and I write 20. I can write 2 right here and not worry about this at all. Or I can write 20. But there's no reason to say write a happy face or an X or the mother's maiden name or a flower. All of those things our elementary colleagues do, which is not mathematical at all. It is a silly thing happening there. And then I see there's 10 times 10 is 100, so I record in the most efficient way, 1 in the hundreds place. But you see, I'm interested in the whole area. This is parts to whole, so I must add, and therefore I found 6 and 156. Notice 3 things which are achieved: the language, the concept, and the procedure. Now that is at the 2nd or 3rd grade level. Now let's go a little further. I'm going to define this piece, yellow piece, now as 1 by 1. If this is 1 by 1, then what should I call this piece? Well, this becomes 1 by 1/10, because if I put it there, this is 1 and this is 1/10. And if this is 1 by 1/10, then this area is 1/10. So the name of this is 1 times 1 equals 1. And the name of this is 1 times 1/10. Now what should I call this piece? Well, this is 1/10, this is 1/10. So it is 1/10 times 1/10. But what is the value of 1/10 times 1/10? Look at that. It is 1 out of this 100 pieces. So therefore the area must be 100. All right. So now I'm ready to multiply 1 and 2/10 times 1 and 3/10. 1.2 is about 1. 1.3 is about 1. So I have 1 times 1. Now my vertical side must be 1.2. So look at this. 1.2 times 1, 1 and 2/10. Very good. Now the other side must be 1/10. So this is 1 and 1/10. This is 1 and 2/10. And this is 1 and 3/10. And now I have to make this into a rectangle. So here is my rectangle. And I have represented concretely, and you are seeing pictorially, 1 and 2/10 times 1 and 3/10. Let me see what's the answer. 1 whole, 2/10, 3/10, which is 5/10, and 600. 1 and 1.56. Or isn't that 10 hundreds, 20 hundreds, 30 hundreds, 40 hundreds, 50 hundreds? So 1 and 56 hundredths. That is extension of the same model, same material, same representation for decimals. Now I want to do a problem, but I want to rename these things. I'm going to call this as A times A, and therefore the area is A squared. So if this is A times A, I'm going to call this as A times 1. So now I have A plus 1 times A equals A squared plus 1A. And if I put this one here, then I have A plus 2 times A, which is A squared plus 2A. Now I'm going to put these here. So now it becomes A plus 3. And if I complete this rectangle, I have this area. And let me represent it. So this is A plus 2 times A plus 3. Look at this. This is A times A. So A times A is A squared. Look at this is A times 3. So A times 3, that is 3A. And look at this is 2 times A, so 2A. And then this is 2 times 3, which is 6. And we have A squared plus 5A plus 6. Notice the same material, same model, same language. That is what I mean by trajectory of a mathematical idea. Not demarcated, not compartmentalized, not isolated. Now they can see that they can apply to any concept. So every arithmetic concept, when we extend it, what we call as arithmetic algebra, the transition from arithmetic to algebra becomes very smooth and very easy. And if we do that, more children will be interested in mathematics. I remember a personal incident. When I reached 9th grade, I was at New College at that time, and our headmaster, yes, Dr. Rajput, I will stop there and I'll come back to the
No, you please complete your story and then I'll ask a question.
Okay, so the headmaster welcomed us. He was an ex-mathematics teacher, so he always gave his examples in mathematics. So he said to the 9th graders, those who know their multiplication tables will be taking calculus in their final year, and those who don't know your multiplication tables, don't come back. Now that was very harsh, and some of my friends and I laughed that how could it be possible that they won't know multiplication tables? This is my 56th year of teaching, and I found, today I would say, if a child does not know the multiplication tables with understanding by the end of 3rd grade, algebra will be difficult for them, and naturally they will not reach calculus. As a matter of fact, data structures will be difficult also. So there are what I call as non-negotiable skills at each grade level. So in elementary school, kindergarten is number concept, just one concept. In 1st grade, addition, 2nd grade, subtraction. So by the end of 2nd grade, we have additive reasoning. 3rd grade, 4th grade, multiplicative reasoning, then proportional reasoning, then algebraic thinking. So transition to algebra becomes much easier when a child has good understanding of arithmetic. As a matter of fact, it's not difficult at all then. Children have difficulty because we give them as a procedure. Do this, do this. How do you multiply binomial terms? Do binomial, FOIL, do this, do that, and so on and so forth. They are not mathematically sound. They are not extensions. They are not abstractions. They are not connected. So, Dr. Rajput, please.
Yeah, we have got 2 questions. One is from Madhvi Verigonda. She is asking you to just give an idea how division, simple division can be done as you explained multiplication, but not maybe at length as you described multiplication, but how division can be associated with this.
Sure, absolutely, absolutely. So let's take a problem. So 17 divided by 3. So I'm going to take the first model of division. What was the first model of multiplication? Repeated addition. So what am I going to ask here? How many sets of 3 are there in 17? So here is my 17. I always start a mathematical idea at the intuitive level. Notice my first question was, what was the model for multiplication? That is intuitive level of knowing. Second is concrete. What is the most efficient way of making 17, 8, 10, and 7? Now, here is 3. How many sets of 3 are there? 1, 2, 3, 4, 5, and I notice that I cannot make another set of 3, so I have 5 sets of 3 and something left over. Well, I have used, and let me see, 2, so remainder of 2. Not only that I see the remainder is 2, but I also see that this 2 is not a whole group. It is part of that group 3. And what part is that? It is 2/3 of that. 2 out of 3. So my answer is what? 5 and 2/3. This is by repeated addition. Now, the second definition of division is partition. If I divide 17 into 3 groups, what will be the size of each group? I divide 17 into 3 groups. They are equal groups. What will be the size of each group? Now notice, that is a very limited definition. So one group, second group, one group, And I keep on doing this. And notice I'm only learning counting there. And therefore that's not a good model. I made 12, 13, 14, 15, and I have 2 left over. As a matter of fact, I have, oh, that's 12 only, so that must be right, so right there. So repeated subtraction in this case was more efficient than partitioning because you will end up counting there only. The interesting part is that it gives rise to something. Look at this one here. So I have a rectangle here, 3 times 5, and there's a partial rectangle. I can actually cut these into pieces, and I made a few more of thin ones there. And actually, I could have used this. 3, 3, 3, 3, and the 2. 3 times 5 is 15. So in other words, I'm asking, 3 times what is 17? Well, I know it's 15 makes a rectangle, and that's a leftover, and that's a portion of that. Now, the question arises, how do we take it further? So let's take an example. I'm going to take an example, 127 divided by, before I go to that, let me take that 3 times 4 multiplication. And I'd like you to look at this. Please read this as a multiplication. 3 times 4, 3 times 4 is 12. Notice, 12 is 3 times 4. Notice, this symbol which you see, or when you see it on that, where does this symbol come into place? That is from the area 12 divided by 3. In other words, what is the largest possible rectangle can I make from 17 with a vertical height of 3? What is the largest possible rectangle can I make from 17 of vertical height 3? I can make this rectangle. This is the largest possible rectangle with a vertical height of 3, and then 2 is left over. So now let's take this problem. 127 divided by 6. How do I make 127 effectively? Well, I can make it, here is 100, here is 20, and here is 7. Let's read this as a division problem. 127 divided by 10 equals 12 and 7 left over. You see the group of 10 and a 10 and a 10 and a 10? So if I divide 127 by 10, my answer is 12 and something left over. If I'm dividing by 6, naturally my quotient is going to be larger because my height will be smaller. So what do? So we cannot make a group of 6 at the hundredths level. So I exchange this 100 into tens. So here are the tens. So I have 127, but I want to make the largest possible rectangle with vertical height of 6. So look at this is going to be my vertical height of 6, and I make the largest possible rectangle of vertical height 6. How many groups of 6 are there? If I take the 6, look at that. 1 group of 6, 2 groups of 6, 10 groups of 6, 11 groups of 6, 20 groups of 6. So I have 20 groups of 6. How much have I used up? I have used up 120. What's left? I've left with 7. Notice, I can make a rectangle of vertical height of 6, which looks like this. So I have one more group. And therefore, I have 21 on the horizontal side. So my answer is what? 21 whole groups and remainder of 1. But this 1 is really a portion of that group. So I can write it as 21 and 1/6. And that's how I would introduce the division using the same model as we use for multiplication. Dr. Rajput, the second question.
Thank you very much. Now we have another question from Mr. Mohan Sharma, who says that in every class we have children of different levels sitting in the class. So how can we address requirements of each child in the classroom when they are at different levels of learning?
Individualization does not mean working with individual child. Individualization means asking questions appropriate to the child. So, for example, if I'm working on multiplication, all children must be working on multiplication, but the numbers used in multiplication must be at the child's level. That means some children can deal with 2-digit number by 2-digit number, some can deal with 2-digit by 1-digit, and some can deal with numbers smaller than 10. So the concept must be the same, but the problems must be different. And then those children, as a matter of fact, the classroom lesson must be divided into 3 parts. So here is my one lesson. This I call as tool building. 25% of my lesson must be devoted on tool building. Now, what do I need for tool building? Suppose I'm teaching multiplication. I need 4 tools. And the 4 tools are 45 side effects, making 10, teens numbers, and decomposition, recomposition. So I must devote this time with all the children orally. Now how do I differentiate? When I come to a child who knows the material already, so one child I ask 8 plus 7, tell me what is 8 plus 7? 15. How did you arrive it? I took a 2 from 7, gave it to 8, that became 10, 10 and 5, 15. Another child I asked the question, what is 88 plus 7? How do you make it? Oh, I made 88 into 90, taking a 2 from 7, 5's left, 95. Another child I might ask 188 plus 7. So your questions must be different, but they must use the same concept. I'm using the same decomposition, recomposition of 8 and 7, but the questions are at different levels. That's how we do one level of integration. Second level of integration, so the second part is 50% on the main concept. That you are teaching to all of them, starting with concrete. As a matter of fact, you will find when you start with the concrete, the low-performing children, which we think are low-performing, they actually are better in fine motor coordination, spatial orientation, space orientation, and those who have memorized Rattabaji, they can't even make the model, and therefore these children sign there. So main concept, all children are working on the same concept, using concrete materials, pictorial materials. And the third 25% is reinforcement. Here, I must devote more time with those children who are at the lower end of the spectrum, so that I can bring them up. And that's how I will integrate them, differentiate, and develop some cohesiveness in the classroom. Next question.
Thank you very much, Dr. Sharma. Such a nice explanation of how the children of different needs may be taken up in the class. We have another question which is on the chat box. that is from N.K. Laishram, and he wants to explain you the process, how do we come to the conclusion that a negative number multiplied by a negative number is producing to a positive number.
Well, let's do that. So I'm going to write this. I'm going to color just because I do not prepare for that, but I will make do my material in a moment. So here is my card, which I'm going to call positive, and this I will call negative. So before I bring to positive and negative, I need to look at this. When we see plus and minus, what comes to your mind when you see this plus? Well, it says add or positive or some, etc. Many words. And when you come to this one, the opposite of these. So what does the minus do? It does the opposite. So if I have this, and if I do the opposite of this, what do I get? So opposite of positive became negative. See, I had positive, and I do the opposite of that. So I'm operating this minus on positive, and the result is negative. Now I operate on this negative. I do the opposite of that, and I do that, and I find I got plus. So use this negative and positive as a unary operation, operating on a symbol. Integers, we have difficulty for 3 reasons. And the 3 reasons are, some difficulties are operating on numbers itself. So when you look at numeral and number, and now I'll ask that gentleman, what is the definition of numeral and what is the definition of number? So please speak up, and if the technology person can focus on that face, I'd love to see that face. So give me the definition of numeral and number.
Mr. N.K. Laishram.
Yes, please,
N.K. Laishram ji, please.
Yeah, yes.
Tell what is numeral and number.
What is a numeral and what is a number? Hello?
And Mr. Laishram, not your assessment, whatever you know about number and numeral, please come up. Don't fear.
Well, listen, how do you expect your students to be fearless if you are fearful? Unless you are a student also. All right. I'm going to give a definition. Numeral is a representation of quantity. So if I look at this card, you see a quantity on this. There are 8 things there. Number is a directed numeral. In other words, when I say, I walked 3 miles, I will write 3. But if I say, I walked 3 miles in forward direction, I will write plus 3. I walked 3 miles in the backward direction, I'll write minus 3. So plus 3 is a directed numeral. Minus 3 is a directed numeral. And a directed numeral is called a number. As a matter of fact, number is one-dimensional vector. In other words, it has a quantity and also has a direction. 3 is a numeral. There is no direction. It's neutral. It's the object, 3 objects. So now notice here, there is 8 is the quantity, but the color is black. So now this is also 8 as a numeral, but the color is red. So I'm going to call this as positive 8, and I'm going to call this as negative 8. You have heard in business there's called in the red, you're losing money. In the black is making money. So positive 8, negative 8. So when you are teaching integers, you must differentiate between numeral and number. Children have difficulty because they cannot distinguish between the numeral and number, and therefore they have difficulty in operating on that. I'll urge you to join me on my one of the webinars. On Tuesday mornings I give a webinar at 8 o'clock American time, and it will be your time will be 6:30 in the evening, so you are not in school or you are not in college, so attend the webinar. And this week I'm working on multiplication, how to teach children multiplication. I start these webinars in September, and all the way throughout the year I take them from number concept all the way to algebra. So if you attend them regularly, you will have the whole curriculum from pre-kindergarten to algebra, including geometry. So join me and I'll give you more of that.
Thank
All
you
right.
very much, Mr. Sharma. Yeah, so maybe we can take one question very hurriedly, because we have some children, some students who are sitting offline also in our regional institute at a venue. And if there is one question which we can take, and we had a very nice presentation, so maybe one question from the students sitting in RI Mysuru.
Good morning, sir. Myself, Ashfaq, student of RI Mysuru. Sir, in India we have two paradoxical statistics. One piece of data says that our enrollment rate in primary schools is about 97%. And other piece of data says that there are about more than 50 million students who lack basic literacy and numerical skills in India. So this data is very much concerning, and overcoming this should be top priority of any nation. So since you are living in abroad and you have experience of 56 years of teaching in mathematics, how do you see other nations' attitude towards this problem? What initiatives they have taken and how India can learn from them?
Well, to have effective teaching, you can stay so that you can, okay, good. To have effective, meaningful teaching, there are three components: the curriculum, the teacher, and the instruction materials. Curriculum, NCERT is very good at creating the curriculum. My observations, teacher training is not very effective, and the materials are also not efficient. And as a result, we have inefficient way of teaching mathematics, and therefore children work very hard, but they do not achieve the level of mastery they can. The other thing is that in Indian education, because I'm a product of Indian education, and I have visited, I have relatives, I have nieces and nephews, there is no emphasis on the language of math and the concepts of math. You can only go that far when it comes to mastery of mathematical ideas if you're only teaching procedures. I have asked many teachers whenever I visited India, can you please prove to me why do you multiply 1/2 times 1/3 by doing 1 times 1 is 1, 2 times 3 is 6. Or you please show me concretely how do you come to inverting that 1/3. And no, the answer is not given. So we focus on procedures and we not related to language and concept. That's the problem. Now that's not an Indian problem only. It is all over the world. There are only 3 or 4 countries where I could say that the education integrates language, concepts and procedures. Otherwise, most of the time, the focus is on procedures. And teacher training is definitely one of the major factors. Teachers teach, not books. Teachers teach, not materials. Teachers teach, not curriculum. So if the teacher training is not adequate, then we will continue to have that astoundingly worrying data.
Thank you very much, Dr. Mahesh. Any other question from RI Mysuru students? Or otherwise, then we'll close this session. There is a question.
Good morning, sir. I'm Sadhna, currently pursuing MSc at Mathematics in RI Mysuru. Even though the teachers nowadays know a lot of teaching strategies and effective resources, due to time boundness, they can't complete the syllabus if they start using these resources for a lot of time. So due to that completing the syllabus, they won't use the learning resources. So what are the ways that the teachers can use the time in the classroom effectively so that the students can learn this mathematics and develop the abstractness using resources?
Well, you made three assumptions in your question. One is that they have good resources, and second assumption you made that they have good strategies, and the third one that you didn't say but you assume that the curriculum. I have my questions about strategies. I have seen these booklets for children. Every time addition is defined as count up, subtraction is defined as count down. I want you to look at this problem, a simple problem, and I'd like you to, since all of you speak quite good English, I'd like you to tell me what does this mean to you in English. Give me an English sentence. I want from students statement, read it, and I'll write it in English. Read this one for me, please, in English.
Subtracting 9 from 17.
Subtract 9 from 17, you get what? All right, good. Keep on, please. Somebody else? The student body. As a matter of fact, this question, the answers will be directly counted towards your MSc exam results. So give me the answers. Well, that proves my point, that if you knew to read it several ways, then you would be an effective teacher. You have read only one way. Hello?
I think they don't have any different way of putting it up. Say for example, what is there is one student.
Yeah.
Sir, what we need to add to 8 to get 17? To 9.
Did I write 9 plus what equals 17? Is that what did I write? I'm asking you to translate this into English.
17 minus 9.
17 minus 9 equals what? Somebody else. Is he only looking for about 15?
Actually, he asked what is to be added to 9 to get 17.
Yeah. What do I add to 9 to get 17? You'll be translating this equation.
Yes.
I want this equation. Translate it. Hello?
X plus 9 equal to 17.
Sorry?
X plus 9 equal to 17. He's saying x plus 9 is equal to 17.
We don't have any X or yeah. See, now if you are going to teach that first grader, are you going to teach that? So now I'm going to write some of them, okay? 17 subtract 9 equals what? 17 deduct 9 equals what? 9 less than 17 equals what? What is the difference between 17 and 9? 17 is how much more than 9? 9 is how much less than 17, etc. I can write about 10 more. So, if you taught children only these three statements, these are called active voice statements. There is a number, operation, number. These are passive voice statements, and these are indirect statements. Conceptualization is dependent on language and the model. These children who only saw this one will not be able to do good problem solving. Word problems would be difficult for them because the only thing that they can see is a direct translation. When they say, David is 17 years old, And his sister Emily is 9 years old. How much older is David than 9? There is no takeaway, there is no subtraction, there is no minus. You say, I can't do I do addition here? Do I do subtraction here? So that is not an effective language, and therefore the children have difficulty. So language is first, concept is second, procedure is third. In our country, procedure first. When we have time, then we do conceptualization. Language, forget about that. Chasatta, there is no grouping, there is no repeated addition, there is no array, there is no area, nothing. That's why children have difficulty performing on those examinations, particularly international examinations, when they are comparing multiple representations of that. So it's not the books, it is not the curriculum, it is the teacher competence and the delivery of that. Anything else?
I think that was very, very interesting.
One more question.
We will have keep on having questions. No doubt it was so interesting. And I have started learning foundational numeracy, so I enjoyed even this whole talk very, very much.
Yes, good morning, sir.
Dr. Mahesh started with giving a similarity of having an opaque city in language and numeracy, and then came to explaining what numeracy is and how it helps in development of mathematical thinking, mathematical learning, applications, and so on. So he talked at length. No doubt this whole lecture is available in recorded form, and that will be available on the website of this seminar also. But as has been mentioned, Dr. Mahesh is very, very active, and every day he is talking about one or the other concept. So you all made login, made it, and then get ideas what he is speaking. So almost as he mentioned, he used to cover almost all areas of the curriculum of early graders, early grade children. So you will have enough ideas about that. There is one organization with Mr. Sanjay Raghav, Dr. Mahesh is working. Sanjay Raghav is raising hand. Sanjay, you have enough time to talk to Dr. Mahesh. But anyway, if you can say ask your question in 1 minute or add something, you are welcome.
Sir, it's not about the question, it's about anybody who wants to get in touch to a contact so that they can get the access to the webinars actually. So if you can just note down that.
Yeah, go to our website www.mathematicsforall.org, and there is a description of the webinar. There is an ID, there is a passcode, and there you can also see my blog articles are there, and many other resources are there, and some videos of my working with the children and otherwise, and Sanjay's videos and his working with the children. So
thank you very much, Dr. Mahesh, once again, because you spared your time in this odd timing of the day. So once again, on behalf of all the participants and organizers of this seminar, we pay you sincere thanks, and we hope that this support in making teaching learning more effective in our country to young learners will continue. You will continue supporting us from NCERT also. We would like to have your engagement in curriculum development, in teaching strategies, in development of textual and other resource material for children. So thank you very much, Dr. Mahesh. Please be in touch, and anybody who wants to be in touch, the website has already been mentioned, so you can be there. Thank you very much, everybody, for spending your time and to be a patient listener and putting up more questions. So now,
thank you very much, Dr. Rajput. I also want to thank organizers for giving me the opportunity of sharing some ideas, and it's quite 1 o'clock in the morning in Boston, but I enjoyed myself, and I'm an early riser, so now I like to get up early in the morning. Thank you very much.
So we over to Dr. Prasad, who is going to put up a vote of thanks.
Hello. So thank you very much, sir. In fact, Mahesh Sharma sir exactly explained how a teacher should be there in the classroom, not giving more importance on those procedural things, but actually on the process. That's very important. So on the behalf of RA Mysuru and NCERT, so So we are really thankful to you, sir, for your wonderful interaction with the students as well as the important concepts explained. I expect my students to give him a big hand for his excellent presentation, sir. Also, I am really grateful to my beloved Professor Rajput sir, for taking this session. Thank you so much, sir, on behalf of RA Mysuru and NCR. So thank you for all the audience for your patient hearing, and I hope that these things will be helpful when you become teacher in future. Once again, I am thankful to you, sir, for your wonderful interaction. Thank you so much, sir. I hope you will have a good night. We are actually at the afternoon time. We are saying good night to you, sir. Thank you so much. We hope that we will meet you in person in India when the situation is improved. Thank you so much, sir.
Absolutely.
Thank you, sir. Thank you, Rajput, sir.
Thank you. Thanks a lot.
So now we will break for 15 minutes. We will have a tea break now. After that, we will have Subramaniam sir is here. Sir, Subramaniam sir, am I audible, sir? Sir. So we will break for 10-15 minutes. Then we will join back here, and that time Subramaniam sir will be here, and at 11:30 we will join, and we will begin our next session. Vishwam sir will be chairing the session. We will break for tea. Here the session, it is session 3.2 will be starting soon. We have less number of papers here. I think Santosh sir is here from Delhi. Sir is joined from Delhi. Actually, sir is our faculty. RI Mysore Physics faculty. Sir will be moderating the session. Santosh sir.
And even with that time itself, it may be concluding by 6 o'clock today evening, mostly. So I think this will be all right, and I think with the first participant, I think Bahadur BJ, about the title is Foundation Numeracy and Literacy Perspective, NEP 2020, will present the paper.
Thank you, sir. Good evening. I'm very thankful for RI Mysuru for conducting this excellent conference. Myself, Bahadur BJ, a research scholar, RI Mysuru. I'm pursuing my PhD from Dr. Susatha ma'am, RI Mysuru. My topic is Foundation Numeracy and Literacy Perspective, NEP 2020. First of all, literacy means the future ability to read, ability to write, to speak, to spell, grammar knowledge, ability to ability to listen. The overall ability to communicate and make a sense of our world is considered as a literacy. The numeracy, the ability to count, ability to solve a problem, ability to make a sense of time, numbers, patterns, and shapes. The ability to use the mathematics with confidence and efficiency. That's considered as a numeracy. As we know, the main ultimate goal of education is to make a future literate. Everywhere we are using the literacy and numeracy. For example, at home, in our family, we are using literacy and numeracy.
1 minute, Adarsha, can you put that presentation into the full screen mode so that it will be more visible? Can you try once? I'm sorry to interrupt. Better, continue.
We are using the literacy and numeracy at home, at school, at library, on markets, bus stops, in restaurants, etc. Everywhere we are using literacy and numeracy. Some few examples for literacy and numeracy in everyday life. Searching for the right places, looking for a special product brand, waiting fruits and vegetables in markets, checking an item choice, paying at the cashier, etc. etc. Numeracy in early years, mathematics is one of the specific area that we teach in foundation stage. It's split as two areas. First one is numbers and second one shapes, scales, and measures. Mathematics starts every day through play, after, and through direct and art and activity. The increased focus on foundational numeracy and numeracy including reading, writing, speaking, counting, arithmetic, and mathematical thinking. Literacy and numeracy are foundational for all students. Learning literacy is more than just the ability to read and write. And numeracy is more than the ability to solve a number problem. There are means of discovering and making sense of the world. As we know, literacy is a person has the ability to identify, understand, form, shape, and complete varied contexts in behind the chapter. Numeracy that means person has the confidence and mind in terms of critically assess listen upon applied in their and judgment or decision and taking action. New Education Policy 2020, Foundational Literacy and Numeracy and these two levels. The NEP 2023 reduced 5 plus 3 plus 4
Others, I request Mr. Prem Prasad to mute yourself.
The main issues in education, too much EP by teachers with inadequate mathematical knowledge, poor quality of entrance to profession, is to basic training courses, retention rate of creative and talented teachers, too much change to curriculum and assessment, centralized control and decision taken by inappropriate people, too little trust in system, unprecedented investment in mathematics education. Mainly, mathematics teacher issues and concerns are basic knowledge, connection to real life, kids with mathematics block, dealing with objects, needs for after schooling tutoring, homework issues. And some solution for principal tutor problem. Teacher already know arithmetic and how many are just 14. Kids fight, lack of materials, topics to sort out, one problem just solve another one. And parents complex. Strategic plan includes following steps related to numeracy. First, people's principles of learning into our literacy and numeracy strategies. Developing inner city early learning, developing and adoption of teachers, mentor and leadership programs. Re-emphasizing our commitment to proficiency for 21st century throughout the curriculum. Thank you.
Thank you, Adarsha, for presenting. So now the platform is open for interactions and questions. So from the participants who listened for this paper presentation, do you have any questions? You can ask. Those who are interested to ask questions, or even you can make some comments or suggestions or whatever be that, you can unmute yourself and speak.
Yes, sir.
Gopal sir, little bit louder.
Am I audible?
Yeah, better.
I want to ask Ajay sir, you have taken up this topic of foundation, numeracy and literacy, perspective for skill policy and education. What is his major suggestion? Because that age is a very critical age, wherein like a normal child you can't teach them. That is the age where the school is going is not actually taught to them. He is not interested in going to school. How to make it attractive? How to make this learning more joyful? This is very toy pedagogy or something like that, or is this mathematics to some kind of a special device? That's what you are supposed to tell us in your research. So that in the policy document, straight away those things can be implemented, and then we can come out with a good kind of a strategy. That is what is envisioned in this conference. Can you tell some suggestions? Probably either Sujata or probably others can tell on that. Yes. Yes, sir. This is my question. Yeah. So actually, in classroom situation, teachers directly interacting with students in one-way communication. Suppose if you want to teach A plus B whole square, directly we are telling A square plus 2AB plus B square. Student doesn't know the meaning of what it means. Actually, sum of two numbers that is equal to square of first number and square of second number, and the product of first and second, and double the sum of all these three gives the meaning of A plus B whole square. So all teachers not giving proper information about this formula. Like this, we have to give the application level teaching even for the preschool children. As others, this is that my question. You are talking about the foundation, numeracy and literacy for whom? The foundation is the only that small school children, you know, LKG, UKG and all. You are talking about literacy, hope that there is something else. Huh? Where you are? Where you are? I am talking about whatever you are talking to your teacher. For certain suggestions as well. Yes, you have taken a very good topic. Excellent. Then, think about these suggestions. What kind of pedagogy should be adapted? Because normally you all say that the andragogy should be applied to your adult children. Like the pedagogy when we are talking to very small children who are just trying to go to school. So those kind of children it's very quickly and that's what. That is the whole essence of the time. Yes. As I said, we need to teach an application level. For example, if you want to teach for preschool children 2 into 2 is equal to 4, we need to draw two lines, two parallel lines and two interacting lines, intersection lines. The intersecting point that gives the product of 2 into 2. In this way, if you teach for the pupil, they will get understand mathematics easy. Okay, that's what we are telling you. But then, that is really have you tested? Have you gone to a school where you are tested? When the children are most of the children I have seen in our LKG, can you make it louder? They will be like they're going there and there. They will not be interested in it. They will be interested in playing. They are better how to use your mathematics or counting some toys. For example, somebody was telling in one hand they have got. Okay, the teacher has given this hand is giving one answer. Okay, one. How many answers they have given? One. And the teacher writes and wrote on the head, this particular hand has given one word. Okay, one is learned by problem. That kind of stuff, we want the children to get reduced, attracted, to learn that subject. There is mathematics and biology. If until and unless the child is not interested in learning this, through which we have to attract the attention of the learner. Learner focus is more important for the teacher. Now, what is the focus? What is the thing that you can do? They will get attracted. I think probably mathematics as such is a subject is very wonderful. If they add some kind of this kind of technology or that's what they do to tell instead, some kind of a pedagogy of thought, pedagogy or whatever you can call, which attracts the children at that level and that age. Because the psychology of the child at that age is really always very close. It's not interested in sitting in the four walls tightly like we and want to hear because that is the age for children. We can't revise it. So probably we all have passed that age, so we don't know how it went. But that is the stage in grade. If you want to teach him how he will learn, how it will be more effective, what strategy as a mathematics teacher you will adapt for important things. So, there is some kind of a thing, okay, you draw some lines so that one means one, two like that. That's also one kind of a thing. But other than that, it should enthuse the children. Yes. Yes. Thank you, sir.
Thank you, Gopal, sir.
So many models like a streetway, playway, kindergarten, review, those things you could have highlighted. I would have been more happy you could have highlighted those things and it would be very interesting in your paper. Because that is the thing, like ability to read, ability to write, ability to speak, ability to spell, ability grammar knowledge, ability to listen. All these things are language skills what you have written. But other than that, some mathematical kind of thing. Suppose if you do experiment or if you say that a story telling, something like that, or a toy you bring it and make there, this is very one egg in front of it. Just say they count it and then they say, oh yes, this is doing one. Probably second hand, another 2 eggs. Probably the teacher might have only given it 10 eggs. So he wanted to tell
Gopal sir, our time is for this session is almost coming to an end. Sir, I just wanted to bring it to your notice.
Once, if you give me just a minute, I'll respond to what Paul has asked.
Okay, madam, 1 minute you can take, madam.
This is actually this work that Adarsh has taken up. This is much before NEP 2020 has come. Already started working on foundation literacy, numeracy, and he is using one Reggio Emilio approach for the preschool children. He is working on them. But this paper is not about how we are going about teaching literacy, numeracy. This is just a conceptual framework of what NEP 2020 from that perspective only it is talked in this paper. His research is in this area. So that I wanted to make it. So mostly it is most about the playway method of teaching that is being adopted for teaching numeracy as well as literacy at the preschool level. That is his area of research using a Reggio Emilio approach that he has used. I just wanted this. Yeah, thank you, sir. Thank you for your time.
Okay.
Thank you, ma'am. Thank you.
Okay, thank you so much. And again, the second participant, what is his name? Yeah, Dr. Rekha Rani Kapoor. Please, you say clearly what actually you are trying to do and what you have done, and you have already told in your abstract that developing TLM gives examples of TLM. It is sufficient if you just give 2-3 examples and how they are useful in increasing the numeracy among the primary children, early teaching of mathematics, how it is useful. That is sufficient. Don't tell about the history and all those things. Okay, thank you. Please continue.
Good afternoon, everyone. I am Dr. Rekha. The title of my paper is Reflections on Development of Locally Contextualized Teaching Learning Material in Ensuring Foundational...
1 minute, madam. Others, you can stop sharing the screen so that the other persons can start sharing. Others?
Sir, I haven't prepared PPT.
Okay. Anyway, others has to stop sharing. Why? Because the next person may need that one. Others, I request you to stop sharing the screen. Madam, please continue.
I have an opportunity to share screening because I am just presenting my paper, sir. Maybe some other person has taken that. I think Dr. Adarsha was presenting his paper on screen.
Okay, madam.
He had to stop screen sharing.
Yeah, I was requesting Adarsha, not to you, madam. I just interrupted you. I'm sorry. Continue, please.
Okay. The title of my paper is Reflections on Development of Locally Contextualized Teaching Learning Material in Ensuring FLN. As Sir has suggested that I need to give examples. So I have taken one material development project, and the title of my material development project was the development of locally contextualized TLM in ensuring FLN. जैसे अभी मॉर्निंग में भी सेशंस में there was discussion and Dr. Hukum Singh has shown various examples of daily life things like boxes and all these pizza box, how these boxes and how these locally available things can be used in the field of mathematical teaching. Dr. Vijayan sir has also suggested that students' experiences also important contribute a valuable learning resource in teaching learning process. So my paper is on the similar lines. So the development of teaching learning material. So right now we have developed certain activities. So I am giving examples of activities. These activities are pertain to class 1 and 2. गतिविधि है कबाड़ से जुगाड़। कक्षा प्रथम अनुमानित समय सीमा 30 से 40 मिनट की है और गतिविधि का प्रकार है सामूहिक कक्षा कक्षा। इट इज अ ग्रुप एक्टिविटी। और जो आई हैव टेकन डेवलपमेंटल गोल्स एज हैज बीन प्रिपेयर्ड बाय निपुण, जो हमारा निपुण नेशनल
Excuse me, others, I request all others to keep your mic muted because it is disturbing the presenter. Madam, please continue.
FLN document has been prepared by Nipun Bharat by MOE, Ministry of Education. There are three. Next, other participant who please mute your mic. So FLN document has presented three developmental goals. FLN developmental goal 1, that is children maintain good health and well-being. Developmental goal 2, children become effective communicators, and developmental goal 3 is the children become involved.
You muted her also.
Madam, please unmute yourself, madam. I'm sorry. When all participants are muted, you also got muted, madam.
It's okay, sir. I have unmuted myself, sir.
Okay, please.
So, I was saying that FLN document has been prepared, and as we know, FLN document is a recent document in the field of FLN, and it has shown there are 3 developmental goals that need to be taken care of. So my activities pertain to these 3 developmental goals, and the emphasis is on the development of locally contextualized TLM. So right now I have prepared activities. This is the material development project undertaken by SCRT Delhi. So I am the project coordinator of this project, and in the next year I am going to develop, it is in the pipeline, it is in the process, I am going to develop integrated teaching learning material kits in the field of Hindi, English, Urdu and Punjabi. In Delhi all these 4 dialects, all these languages are used. So right now I have prepared activities in Hindi. So I am sharing those activities. गतिविधि है कबाड़ से जुगाड़, कक्षा प्रथम अनुमानित समय 30 से 40 मिनट, और it is a group activity. जो इसमें अधिकतम प्रतिफल है, जैसे विद्यार्थियों के लिए आगे और पीछे की संख्या बताना। जब हम न्यूमरेसी के कॉन्सेप्ट्स कर रहे हैं, एफएलएन के कॉन्सेप्ट्स कर रहे हैं, जिसमें हम कह रहे हैं कि बच्चों को जो नंबर्स हैं, ऑपरेशंस और नंबर्स आने हैं, तो किस प्रकार से हम सामान्य जो दैनिक जीवन की उपलब्ध सामग्री है उसके द्वारा हम किस प्रकार से उनको ज्ञान दे सकते हैं। तो इसमें पुरानी माचिस, गत्ते का टुकड़ा, रंग बिरंगे कागज, फेविकोल और स्केच पेन आवश्यक सामग्री है। तो शिक्षक सभी पुरानी खाली माचिस पर रंगीन कागज चिपकाकर उसे कवर कर लेंगे और फिर उन माचिसों के बाहरी भाग पर 1 से 20 तक की संख्या लिखेंगे। अंदर वाले भाग पर शिक्षक आधे भाग में 2-2 संख्या लिखेंगे और उन सभी माचिसों को गत्ते पर चिपका दिया जाएगा। शिक्षक माचिस के अंदर वाले हिस्से को स्लाइड करके बच्चों से प्रश्न पूछेगा कि बच्चों बॉक्स के ऊपर कौन सी संख्या लिखी हुई है, तो वो ऊपर बताएंगे, इस संख्या के आगे की संख्या बताओ। बच्चे अपने उत्तर बताएंगे और माचिस के फिर अंदर वाला भाग स्लाइड करके दिखाया जाएगा। इस प्रकार से उनके उत्तर की जांच भी होगी और जॉयफुल लर्निंग भी होगी। इसी प्रकार से उसके पीछे की संख्या भी, क्योंकि हमने स्लाइड में दोनों ही संख्याएं लिखी हुई हैं आगे पीछे, तो फिर हम वो स्लाइड करके दूसरी बार दिखाएंगे और बच्चों से इस प्रकार गतिविधि के द्वारा आगे और पीछे की जो संख्या है 1 से 20 तक की ही लिखी है इसमें, इस प्रकार से गतिविधि कराई जाएगी। इससे बच्चा आरोही और अवरोही क्रम भी सीखता है, गिनती सीख रहा है और विद्यार्थी में उत्साह और उत्सुकता की भावना। सबसे ज्यादा इंपॉर्टेंट जो है, जो एनईपी डॉक्यूमेंट बार बार कह रहा है कि टॉय बेस्ड पेडागोजी, इंडिजिनियस लर्निंग, प्ले बेस्ड अप्रोच, एक्सपीरियंशियल लर्निंग, इस पे एम्फेसिस देते हुए बच्चों से गतिविधियों के माध्यम से सिखाना और जो आसपास अवेलेबल उपलब्ध सामग्री है उसी के आधार पर गतिविधियां करवाना। गतिविधि संख्या 2, आओ भर लो, बोलो किसने कितना पाया। ये कक्षा 2 के लिए है। अनुमानित समय 30 से 35 मिनट है। इसमें हम बच्चों को मैदान में ले जाएंगे। कक्षा कक्ष में भी गतिविधि हो सकती है, लेकिन ये मैदान के लिए अच्छी उपयुक्त गतिविधि है। अधिकतम प्रतिफल जो मैंने इसमें लिए हैं, लर्निंग आउटकम्स, वो सभी डेवलपमेंटल गोल्स में जो एफएलएन डॉक्यूमेंट्स में दिए गए हैं, सारे एफएलएन डॉक्यूमेंट में 3 डेवलपमेंटल गोल्स के जो भी लर्निंग आउटकम्स है उनको कवर करते हुए ही एक्टिविटीज बनाई गई हैं। तो उसमें है विद्यार्थी खेल या कार्य को आनंद के साथ, सहयोगात्मक व्यवहार के साथ और आवश्यकता पड़ने पर नियमों का पालन करते हुए नेतृत्व करके सीखता है। और इसमें सामग्री जो रहेगी, आवश्यक सामग्री, कंकड़, जैसे ग्राउंड में बच्चे जाते हैं जो उनको आसान से ट्विक्स मिल सकते हैं, स्टोन मिल सकते हैं, इजीली अवेलेबल गिफ्ट्स मिल सकते हैं, फेदर्स मिल सकते हैं, कंकड़ या टॉफी या विभिन्न आकृतियों के कटआउट भी हम प्रयोग कर सकते हैं। इसमें सर्वप्रथम शिक्षक विद्यार्थियों को मैदान में गोल घेरा बनवाकर खड़ा करेंगे या कक्षा कक्ष में बिठवाएंगे। एक बॉक्स में सभी कंकड़ या टॉफी को एक साथ रखकर निम्न पंक्तियां लय में गाया जाएगा। साथ साथ हम गाने के द्वारा भी इस गतिविधि को करें। आओ भर लो मुट्ठी, बोलो बोलो किसने कितना पाया। सभी विद्यार्थी अपनी मुट्ठी में आई टॉफी या कंकड़ को गिनेंगे। जिनके पास सबसे ज्यादा कंकड़ आएंगे उसको हम लीडर मानेंगे। लीडर बना विद्यार्थी जो है बाकी विद्यार्थियों की मुट्ठी में भी आए कंकड़ों को देखेगा, उनसे उनकी संख्या बारी बारी पूछेगा। विद्यार्थी शिक्षक जो है मिलकर शिक्षक विद्यार्थियों की सहायता से ही श्याम पट पर बारी बारी से खेल खेलने वाले विद्यार्थी का नाम लिखेगा और विद्यार्थियों का आगे कितने कंकड़, किसके कंकड़ कितने मुट्ठी में आ रहे हैं, कहने का अर्थ है गिनती की जो संख्या है वो फिर साथ साथ में उनसे जुड़वाना, 2-2, 4-4 बच्चों के कंकड़ आपस में जुड़वाना। इस प्रकार से उन्हें जमा की भावना का, जमा की भी प्रकार सिखाया जाएगा। इसी प्रकार से प्रश्न पूछ के कम, किसके पास कम, किसके पास ज्यादा, आरोही अवरोही इस प्रकार से आसान तरीके से कि तुम्हारे पास कितने ज्यादा है, किससे कम है। इस प्रकार से तुलना करना सीखता है बच्चा, तुलना करना सीखता है, गिनती करना सीखता है, आरोही और अवरोही क्रम में खेल सीखता है। और अगली जो गतिविधि है वो है आओ दौड़कर उड़ते और उड़ाते हैं। इसमें ये बाहरी और एकल गतिविधि दोनों के रूप में प्रयोग की जा सकती है। इसमें बच्चे जो है नियमों का पालन कर रहे हैं, तार और गतिविधियों का आनंद लेते हुए खेलों में भाग लेते हैं और इसके अलावा आंखों और हाथों का मानसिक शारीरिक समन्वय और शारीरिक कुशलता का प्रदर्शन करके सामर्थ्य, विवेक व निर्णय लेने की क्षमता दर्शाते हैं। इसके लिए जो आवश्यक सामग्री है वो अखबारी कागज, रंग, फेविकोल, सजावटी चीजें और फीता है। तो शिक्षक बच्चों से इस बारे में पहले चर्चा करेगा, इन्फॉर्मल डिस्कशन, कि उड़ने वाली चीजों के बारे में बताएं। उन चीजों पर भी चर्चा करें जो स्वयं से उड़ पाती हैं या जो स्वयं से ना उड़कर किसी दूसरे की सहायता से उड़ती हैं। बच्चों से बातचीत करें कि वो उड़ना चाहें तो उन्हें किन किन चीजों की आवश्यकता होगी। और फिर यहाँ पे चर्चा जैसे आएगी तो बच्चे पतंग, हवाई जहाज, पक्षी इत्यादि की तरफ हम उनकी चर्चा को निर्देशित कर सकते हैं। फिर बच्चों का ध्यान चर्चा के माध्यम से सभी उड़ने वाली चीजों में समानता, पैनी व चोंच, इस प्रकार से हम लेकर जा सकते हैं। अब हम बच्चों को अखबारी कागज देकर उनको कहेंगे आप हवाई जहाज बनाएं। बच्चे हवाई जहाज बनाते हैं और इसके लिए हम बच्चों को डेमोन्स्ट्रेशन भी दे सकते हैं। कागजों को मोड़ के बच्चे पतंग भी बना सकते हैं। अब हमें इसके बाद एक शुरुआती बिंदु या रेखा निर्धारित करके बच्चे को लगभग 20 मीटर दौड़कर शुरुआती रेखा पर छलांग लगाकर कि आप हवाई जहाज इस पर फेंकें कि वो सबसे ज्यादा दूरी पर जाकर उड़े, तो बच्चा फेंकेगा और वो हर एक बच्चा अपनी गतिविधि को करेगा। इससे हम बच्चों से ये जानेंगे कि कम और अधिक दूरी क्यों गया आपका हवाई जहाज, अधिक दूरी पे कम दूरी पे, किसका कम दूरी पे गया, किसका अधिक दूरी पर गया।
Madam, you have 1 more minute.
अब बच्चों के पास हम इसको छोटे आसान तरीके से बता सकते हैं कि तय करने के तरीके बालिश भी है, पैर भी है, कदम भी है। लेकिन अगर हम कदमों से बच्चों से कदमों से तय करवाएंगे, लेकिन कदम की जो बच्चों के कदम है वो अलग अलग होंगे, तो फिर शिक्षक बाद में फीते की सर आप कुछ कह रहे हैं? जी सर। सर ऐसा लगा मुझे किसी ने कोई इंस्ट्रक्शन दी है।
What did you say? I could not understand. Could you please speak in English?
Sir, I thought that someone has instructed me.
No, I was telling 1 more minute is left for your presentation.
Okay, you were instructing me to wind up my presentation in next 1 minute.
Yes, I was telling, requesting you, not instructing.
I forgot your point. तो इस प्रकार से बच्चों को बालिश पैर कदम बच्चे करेंगे तो उनको बताएंगे कि फीते की सहायता से जब हम होता है तो उसके द्वारा अधिकतम और न्यूनतम दूरी का कॉन्सेप्ट, और फिर हम बच्चों को विद्यार्थियों की सहायता से फीते की सहायता से दूरी मापी जाएगी। इस प्रकार से कई गतिविधियां, और एक गतिविधि है कैरम की द्वारा। कैरम के 2-3 गतिविधियां। कैरम बच्चों के लिए स्पेशल बना के, कैरम बोर्ड बनवा के इस प्रकार से बच्चों को गिनती, जमा, घटा और किसके पास ज्यादा किसके पास कम, इस प्रकार की ध्यान करवाया जाएगा। इस प्रकार से विद्यार्थियों के प्रत्येक बच्चे ने कितने आपने ड्यूटी गई उसके पास, इस प्रकार तालिकाबद्ध करवा के करवाया जाएगा। इसमें जो मुख्य भूमिका है, व्हाट इज द रोल ऑफ टीचर इन एंश्योरिंग एफएलएन डेवलपमेंट ऑफ लोकली कंटेक्चुअलाइज्ड टीएलएम को लेकर हम क्या करते हैं, वो सबसे ज्यादा इंपॉर्टेंट ये है कि जो टीचर्स हैं कि दे आर फर्स्ट जनरेशन लर्नर्स एंड दे आर स्टूडेंट्स हु डोंट हैव एनवायरनमेंट ऑफ लिटरेसी एंड न्यूमरेसी एट होम। लेकिन उनके पास एक इमीडिएट एनवायरनमेंट नहीं है, लेकिन उनके पास एक अपनी भाषा है, दे हैव देयर ओन वोकैबुलरी एंड मैथमेटिकल कॉन्सेप्ट्स आर एवरीवेयर इन डेली लाइफ। चाहे हम शॉपिंग करते हैं, चाहे हम न्यूज़पेपर पढ़ते हैं, बिल आता है घर में, तो दे आर स्कैटर्ड इन एवरीवेयर। कैलेंडर है, तो ये जो गतिविधि का माध्यम इसका है कि जो कक्षा घर में जो आसान तो उपलब्ध सामग्री है, जैसे स्ट्रॉ है, बोतल है, खाली गत्ते के डिब्बे हैं, कागज के डिब्बे, माचिस के डिब्बे, और जैसे बटन है, बिंदिया है, वेस्ट बैंगल्स है, दुपट्टा है, तो इस प्रकार से हम किस प्रकार की सामग्री का प्रयोग करते हुए गतिविधियों का निर्धारण कर सकते हैं और विद्यार्थियों को हम किस प्रकार से एंगेज कर सकते हैं कि वो उसको दैनिक जीवन के साथ एक सामंजस्य बना सके। दे कैन मेक कनेक्शन विद देयर डेली एंड सोशल लाइफ एंड कल्चर कॉन्टेक्ट एंड दे कैन अंडरस्टैंड ऑल दीज थिंग्स। इसी प्रकार से स्कूल में कम्युनिटी रिसोर्सेज के रूप में कुम्हार, बढ़ई, माली या लोहे का काम करने वाले जो सामुदायिक संसाधन, उनको भी कक्षा में बुलाया जाना और उनके द्वारा बनाई गई विभिन्न आकार की वस्तुओं का प्रदर्शन करवाना, कि जैसे कि कुम्हार के भी कई बर्तन होते हैं, उनके भी आकार, बर्तनों के आकार के बारे में चर्चा की जा सकती है। तो इस प्रकार की गतिविधियों को प्रमोट करना बहुत जरूरी है। धन्यवाद।
Thank you, madam. The platform is open for discussions and questions, interactions. I request participants who are interested to ask questions to unmute yourself and ask questions, please.
No one is there? Hello madam, I want to ask you, how is it different from the TLM prepared earlier?
Sir, TLM earlier prepared, that is good thing. But we can see the difference in the TLM. कपास से जुगाड़ गतिविधि एक राज्य में बहुत अच्छे से की गई। HSTP प्रोजेक्ट के बारे में everybody knows, होशंगाबाद साइंस टीचिंग प्रोजेक्ट, बट ये किसी एरिया में किया गया। ये जो प्रोजेक्ट है, it is my जैसे डेली बेस्ड है, लोकली कंटेक्चुअलाइज्ड। आई हैव अर्लियर टोल्ड यू, दिल्ली में 4 भाषाएं प्रयोग की जाती हैं, हिंदी, अंग्रेजी, उर्दू और पंजाबी। उर्दू भी जो जामिया नगर बैठ में यूज की जाती है, पंजाबी भी मतलब एक साइड में। देयर आर 11 डिस्ट्रिक्ट्स इन दिल्ली, तो बेसिकली ऑल दिस TLM and TLM kits will be prepared in 4 languages, Hindi, English, Urdu, Punjabi.
Okay, you have taken up a project and you have delayed. But how practicable that all teachers will follow these things? Is it possible? You feel, is it feasible?
Sir, sorry, I couldn't. You have to please repeat. I earlier understood the question, but right now what you have said, please, you are requested to repeat the question. I request you.
No, madam, what I mean is that as a project you have done it, is wonderful, it's really good.
No, that is running.
No.
The activities are developed.
Yeah, you have done the activities, but is it feasible in ordinary situation as classroom where there are so many students are there, and the teacher is, can he implement the project which you have undertaken? Is it possible?
Yes, we are preparing this, and basically this is also in the alignment of ECC kit and manual. ECC kit and manual have been prepared.
Okay.
ECC means this is the foundational stage, last stage. Foundational stage has been divided into 3 stages. My project is the last class 1 and 2, and the earlier stage for 1 and 1 plus 2 stage. ECC kit and manual has been prepared by SCRT. So this is in the alignment of other things.
Okay, madam, okay, it's all right. But generally what I feel is that even NCRT prepared so many of TLM and all, but when it comes to classroom, they follow the same board method. Okay, anyhow, it's good. Thank you so much.
The TLM kits are prepared, but they are not being used by the teachers. There is another thing, proper orientation and teacher handbooks are also required. Okay. How the teacher put all the things it is very simple. When the teacher makes exponential learning possible in the classroom, there are many things available in the classroom as well. Okay. Nothing like in the school as well. In the school playground, there are so many things that we can do and experiment.
Okay, madam, thank you. The third one is a Mansi Popli. NCRT, Foundational Numeracy and Meaning and the Road Ahead.
Yes, sir. Good evening, everyone. Sir,
Madam, I want to tell you that you have told that you have defined foundational numeracy as it not been defined in NCE 2020, NEP 2020. Next thing is you have told that components of foundational numeracy and provided a roadmap. So just to tell what is the definition you have coined and what are the components and what is the roadmap you have provided to achieve these aims.
Okay, sir. So should I show my PPT or should I just answer your question? Well, should I just go with the definition? Okay. So my paper is Foundational Numeracy, its meaning and the road ahead. Before I try to attempt define foundational numeracy, I have tried to map and see the evolution of the term foundational numeracy from previous policy frameworks. The way our policymakers have seen foundational numeracy or early numeracy to say, I think that impacts a lot on what our children learn in our classrooms. So when we look at National Policy on Education, 1986, the way it has defined foundational numeracy, though the term was not there as foundational numeracy, but the meaning of numeracy was subsumed in literacy. So it has defined literacy, and in that it has mentioned that reading, writing, and ability to, and when children are able to perform 4 basic operations, that comes under literacy. So the way it has looked at numeracy is very different to what we are looking now. It has focused on the achievement of minimum learning levels, and the curriculum for mathematics included that we are following even now. It actually considered कि बच्चों को किस तरीके से numeracy की knowledge दी जा सकती है. It defined very clearly. उसी से आज हमारी जो mathematics की जो किताबें NCERT बना रहा है, I think NCF 2005 played a very important role in that. It also focused on inculcating number sense rather than following fixed algorithms to find one particular answer. But when we now look at National Education Policy 2020, it is the first policy that explicitly used the term foundational numeracy. And it suggested that the goal is to overcome the learning crisis that is already existing in India. And it defined that children need pre-numeracy and pre-literacy as solid foundational stages for learning. Principle of learning, according to NEP, is to provide a solid foundation in counting, arithmetic, problem solving, and mathematical and logical thinking and being trained. So the way it has defined foundational numeracy is way different than what we have been following from so long. National Education Policy has focused on visualization, generalization, and logical thinking. The components of foundational numeracy that has been defined by Dr. Bharat is that it includes pre-number concept. Now that we have included preschool years, Bal Vatika, we have to make a curriculum that involves not just 1, 2, 3, 4 and recitation of numbers, but also pre-number concepts, the actual early numeracy skills that we have been ignoring from so long. Pre-number concepts, number and number of operation on numbers, measurements, shapes and spatial understanding, patterns, data handling, and mathematical communication. Now, I think it's a very, I take it as a honor कि mathematical communication को अब जब हम इतनी importance दे रहे हैं, तो instead of taking mathematical communication when algebra is introduced, now an early numeracy or foundational stages itself and including mathematical communication, I think it's a very important thing that NEP 2020 has included. Now we have to understand that mathematics has its own language and giving its own space and making it as a component, I think it's a very great step. But how we are going to introduce foundational numeracy in our textbooks, I think in various perspectives we have to understand that what are the all other perspectives that takes into consideration early numeracy. So there are 3 views that I have taken here: Piagetian views, German-Lister view, and Corbin-Yapple views. There may be other perspectives as well, which you might not find here. I have tried to take some broad perspectives here. So the first perspective, that is Piagetian view, focused on logical mathematical foundations of the development of number sense. Piaget believed that number sense is the synthesis of conservation of numbers, classification and simulation. So according to Piaget, the mathematics curriculum should consist of one-to-one correspondence, matching and sorting instead of recitation of numbers or counting. But German-Lister view on early numeracy, it includes how to count, it defines 5 principles. उनको 2 अलग-अलग groups में बांटा गया, how to count principle and what to count principle. So the first principle, that is one-to-one principle, means that when children are counting, they in a group, like there are a number of objects that are kept in front of a child. So child points at every object and recite numbers. So the pointing of object on each object is essential. So in early years, children do skip sometimes, like they count either one object 2 times or they skip that object. So that one-to-one principle defines that each object has to be counted in a group. The second principle states the stable order principle. That means the recitation of numbers like 1, 2, 3, 4. The order will remain. The third principle, that is the cardinal principle, that defines that the last number of the group actually defines the number of objects in the group. So if I say 1, 2, 3, 4, 5, the fifth object that I pointed out, it also means that are the number of objects in the group. Abstraction principle, that's a higher principle, that actually means that children not just need to count objects that they can see or touch, they can also count objects that are abstract, that may not be able to see or hear. The next is the order irrelevance principle, that it does not matter if you count the order in which you count. Like if I take 3 objects in front of me, it does not matter that if I count the first object as the first, I can count it as the second object. But it is different on the stable order. In the stable order principle, that means the recitation of numbers in the sequence of numbers. While the order irrelevance is about the objects that are placed in front of us. The next view, that is Cobb, Yapple and Wood's view, gave importance to socio-cultural aspect of learners. Children, according to them, children begin to use first 4 numbers since they are more exposed to those numbers. So according to Cobb and Yapple, the socio-cultural aspect of the child is very important. So the more we expose the child to certain numbers, they are more exposed to them, they are more able to use them. So हमारे आसपास के context का बहुत impact करता है. The next is the counting skills developed in a hierarchical order. That is, only when lower skills are adequately developed, only then higher skills can be developed. So these are the various perspectives that I took. Now coming to your question, how I have tried to define it. I have tried to define it in the same way that we do not need to consider early numeracy as just topic about numbers. We need to understand that early numeracy involves other skills as well, which involves patterns, measurement, shapes and spatial understanding, and understanding that the generalization of patterns and mathematical communication. That's how I have tried to define early numeracy. Foundation. When we look at Hippan Bharat, it has also stated the basic maths पे थोड़ा सा focus है. But in components it has included all that what I'm trying to express here. When I talk about the road ahead, so the first two things that we need to do in moving ahead the foundational numeracy is the textbooks. I'll take an example. जब हम class 1 की textbook देखते हैं तो उसमें numbers को किस तरीके से introduce किया गया है. First they have talked about one-to-one correspondence, like number of objects and a number. So 3 को 3 से like a cup with a saucer. It has introduced one-to-one correspondence. But when you move to next page, it has included the recitation of numbers through poems. But I think that with this perspective and with new education policy, we need to develop, we need to change our text. One-to-one correspondence, but also classification, seriation, and also counting principles and the other perspective that children learn in the socio-cultural aspects. Their stories from them, and literature. Since it's a foundational literacy in numeracy,
hello, madam. You have only 1 minute more. Sorry. You have only 1 minute more. Don't you think that already our NCERT books have all these things?
Yes, sir. I understand that NCERT has taken a very good perspective now,
but you are saying that we have to rewrite the books in a different way.
Yes,
you are
sir.
saying, no?
Yes, sir. That I also am saying. I'm saying that yes, our textbooks are good enough, but we need to take a larger perspective. We have included literacy and numeracy in this new education policy.
Okay, then
So I think that now,
all right. What is the roadmap you have given?
So the two roadmaps that I've, the two steps that I've mentioned here in my paper is that one, textbook development, redefining of textbooks, and teacher education. Well, I think that no policy will ever succeed if we will not change the teacher education system. These are the two steps that I mentioned in my paper, that these two things need to develop, only then our policy on education will be successful enough.
Thank you.
Now it is a time for interactions and questions. People who are interested to ask questions, they can unmute and ask the question.
I hope there is no questions. So now we'll proceed to the next topic. Is it up?
So any suggestion?
Yeah, tell me.
So any suggestion from your side?
No, I find that, of course, you said that you have defined and all those things. Anyhow, you are an NCERT employee. And the next time when the textbook is writing, I mean, you can give your inputs. I don't know, because these concepts of numeracy and all those things, even if you see, we say that problem solving, numerical abilities and all, even in the absence of teaching, the students has the logic in their mind and they will develop it. If you observe a small child, something like 5 years onwards, you can always find in the house itself, he has a logic and he will tell actually some of the numeracy and all those things.
Yes, sir.
In course of time, when he is having a different experience in the home environment itself, before going to school, he himself tells that actual number, how many you need, you want more number, even seriation, I mean in the sense that how many, he starts counting with the fingers, because he will, you said no, one-to-one correspondence. He will,
yes,
suppose he has, I have ordered an object for after 5 days, he will get it, then he starts keeping 5 fingers, every day he will be closing 1 finger daily. That itself indicates that he has, anyhow, it's a good attempt, but okay, anyhow, you can give your input. I think next time there when when NCERT is going to change the textbooks, I think it will be helpful for us. Thank you very much.
Thank you, sir. Thank you, everyone.
Thank you. Next topic.
Madam, can I ask a question? My name is
Yes.
Hanji,
sir.
You are mentioning about socio-cultural from social by contextualizing its socio-cultural aspects. Am I right?
Yes.
Who's doing that? How relevant do you think that we can contextualize, from a historical perspective? For example, if you're teaching, if you're introducing calculus or if you're introducing number theory, why wouldn't we go back to say how the Newtonian ideas developed, and how is ideas from calculus developed by the most trying to figure out the motion of bodies around the solar system, the planetary dynamics. Or, for example, even coming down to the Indian context about how the number system develops in India. Gives some stuff historical basis to it, which sets a context both for history, a bit of inspiration for children, but to have these developments taking place in India itself in ancient past, but also about how the origins actually occur. How do you think that they are relevant? Why is it that pedagogists don't actually incorporate? I'm not a teacher, I'm not a professional teacher. You have some teaching experience.
Yes, sir. Hello. Sir, I think your idea is very relevant. Now that we have included foundational literacy and numeracy, we can take this idea where we introduce numbers through stories. And I think this is something that we can also include in NCERT textbooks, that how zero came into the place. Zero is one of the biggest thing that India has found. So even the Newtonian idea that you said, I think these stories can be molded into some simple literature repositories for kids, which they can explore and they can gain a lot through. And children love reading stories. I think any concept, if introduced in a better way through stories, will be great for our kids as well. So I think this can be done, this can be taken as an initiative by NCERT itself, where they rewrite the textbooks through, and I don't say that everything should be taught through stories.
Madam, we are running short of time. This session's time exceeded. Okay, I just want to bring it to your notice. Yeah, we will go for the next session. Yes, sir.
Trisha Banerjee, issues and challenges to mathematics education with reference to foundational numeracy. Madam, Trisha Banerjee. Okay, you said your findings are large people-teacher ratio, lack of trained teachers, use of conventional curriculum and textbooks, lack of knowledge of teachers in using modern techniques, language barrier among teachers and students. These were there even earlier also. Most of the problems are because of this thing only. Only thing is how to overcome these difficulties will be a better part of it. Anyhow, yeah, you can directly come to that. Okay?
Okay.
Please. Carry on.
I have conducted focus group discussion, and there were 6 teachers. Among the 4 were primary school teachers and 2 were...
Madam, could you please speak a bit louder?
Is it fine, sir?
Okay, continue, madam, please.
Okay. So, sir, I took 6 teachers and conducted a focus group discussion, and the answers there were 4 primary school teachers and 2 Anganwadi teachers. So they suggested that actually there are 2 kind of suggestions. One, I got some literature review. There are the studies which were conducted in Malaysia, and they told that they studied to see the effect of intervention on mathematics, numeracy, and mathematics achievement of primary school students. So they say that early intervention is very important. Early intervention is very important to address any learning problems, because if we intervene the problem at very early stage, then we will be able to decide what kind of solution we have to give them, and then we will move forward. So it is very important, and the members also suggested, members of the focus group also suggested that this can be a very good initiative if we do some basic administration and test the foundation level of the students, and then we will be able to find exact gaps of the students. Then we can design our interventions like that way, so that they will be helpful for them. So we can do that, and there were some other points in the
नीड्स क्या है, क्योंकि वी कांट जज द चिल्ड्रन, बिकॉज कोई है जो बहुत जल्दी सीख जाता है, किसी को टाइम लगता है, हर किसी का सीखने का पेस अलग होता है, हर किसी के इंटेलिजेंस लेवल अलग होता है, हम ऐसे कंपेयर नहीं कर सकते उसको। तो अगर टीचर्स इतने टाइम दे सके और वो स्टूडेंट्स के साथ थोड़ा टाइम बिता सके, उनकी इंडिविजुअल नीड्स को समझ सके, तो हम उस हिसाब से डिफरेंशिएटेड इंस्ट्रक्शन कर सकते हैं, बना सकते हैं। टीचर्स बहुत सारे स्ट्रेटेजीज यूज कर सकते हैं, जिस बच्चे के लिए जैसा यूजफुल होगा, जो जैसे सीख पाएगा उसको उस हिसाब से सिखाएंगे, तो हर बच्चे का लर्निंग हम इम्प्रूव कर सकते हैं। और क्लासेस में जब हम पढ़ाएंगे तो हम पजल्स पढ़ा सकते हैं, हम बहुत सारे गेम्स खिलवा सकते हैं उनसे, और जो क्लासरूम का एनवायरनमेंट होगा वो स्ट्रेस फ्री होना चाहिए, बच्चों को इजीली क्वेश्चन पूछने का फ्रीडम देना चाहिए, और जो पेडागोजी जो यूज करना चाहिए वो मोस्ट ऑफ द टाइम एक्सपेरिमेंटल होना चाहिए, प्ले में होना चाहिए, स्ट्रेस फ्री होना चाहिए। कभी कभी होता है बच्चे टीचर से पूछ नहीं पाते, तो उनके लिए पीयर लर्निंग का भी स्कोप देना चाहिए कि वो अपने साथियों से भी पूछ सके कि इसका क्या है जवाब, या तुमने कैसे किया है मुझे थोड़ा बता दो। ऐसी चीजें उनके लिए वो स्कोप्स देने की जरूरत है। और टीचर्स के ट्रेनिंग्स की भी बहुत जरूरत है, ताकि वो इन चीजों को अच्छे से क्लासरूम में इम्पार्ट कर पाए। और करिकुलम एग्जामिनेशन की जो बात की है एनईपी में, वो भी बहुत ज्यादा जरूरी है, और फाउंडेशनल न्यूमेरिसी की बहुत इम्पोर्टेंट एक प्लेस है मैथमेटिक्स लर्निंग में, तो उसको उस हिसाब से करिकुलम में इंक्लूड करना चाहिए। और जैसे कि एक बहुत बड़ी प्रॉब्लम हो जाती है स्कूल्स में, अभी के जैसे गवर्नमेंट स्कूल्स हैं, कि टीचर स्टूडेंट रेशियो इतना ज्यादा हो जाता है, टीचर्स कोशिश भी करते हैं तो वो टाइम नहीं दे पाते स्टूडेंट्स को, या फिर वो कोशिश भी करते हैं तो वो पहचान नहीं पाते कि कौन से बच्चे को एग्जैक्टली क्या प्रॉब्लम हो रही है, और बच्चा भी वैसे पूछ नहीं पाता। तो जैसे एनईपी में बोला गया है कि पीपल टीचर रेशियो 30:1 होना चाहिए, तो वो इंश्योर करना चाहिए हर स्कूल में कि वो रेशियो वैसा ही रहे, कि वो बहुत ज्यादा ना हो, कि टीचर्स के लिए वो बर्डन ना हो जाए कि उनको पढ़ाना भी है और उनके प्रॉब्लम्स भी नहीं समझ पा रहे, ऐसा ना हो। और जैसे कि अभी के बहुत सारे कॉन्सेप्ट, जैसे अभी जैसे कुछ कलरफुल कुछ चीजें हो जाती हैं, कुछ हो जाता है, तो बच्चे को बहुत इंटरेस्ट आता है चीजों सीखने में, और वो टेक्नोलॉजी के हिसाब से बहुत अच्छे से सिखाया जा सकता है, दिखाया जा सकता है। लेकिन स्टूडेंट्स को वो दिखाने के लिए टीचर्स का जो मतलब टेक्नोलॉजी की जो पकड़ होनी चाहिए, वो उतना वो ट्रेंड नहीं है, तो उनको थोड़ी ट्रेनिंग की जरूरत है। और जैसे कि बेसिक मैथमेटिक्स की एक बहुत भूमिका है न्यूमेरिसी में, और बेसिक मैथमेटिक्स के जो सूत्र हैं, जो उनकी जो टेक्निक्स है, वो बहुत इजीली बच्चों को सिखाया भी जा सकता है। वो अगर सिखाया जाए तो वो जो पहाड़े उनको याद करने की जरूरत पड़ती है, जो टेबल्स उनको याद करने में दिक्कतें होती है, तो वो बहुत इजीली वो चीजें सीख पाएंगे। और इवैल्यूएशन, असेसमेंट, ये सारी चीजों को भी थोड़ी मॉडिफिकेशन की जरूरत है। फॉर्मेटिव असेसमेंट की जैसे बात हुई है एनईपी में, वो हमेशा होना चाहिए, ताकि बच्चों की जो प्रॉब्लम्स है इंडिविजुअली वो हम देख पाए, वो हम समझ पाए कि किस बच्चे को कैसा इंटरवेंशन देना चाहिए, क्या करना चाहिए, वो हम समझ पाए। और लर्निंग एनवायरनमेंट बहुत ही ज्यादा फ्रेंडली होना चाहिए। कोई बच्चा अगर कुछ गलत भी पूछे तो उसको एनकरेज करना चाहिए, क्योंकि एक बार उसके मन में डर बैठ गया तो वो कभी सवाल नहीं पूछ पाएगा क्लास में। तो उसको उस हिसाब से पहले से वैसे सिचुएशन, और टीचर्स को ये समझना पड़ेगा कि हम क्या पढ़ा रहे हैं, इससे भी ज्यादा जरूरी है हम कैसे एनवायरनमेंट में पढ़ा रहे हैं, बच्चा अच्छे से वो एक्सेप्ट कर पा रहे हैं कि नहीं कर पा रहे हैं, वो सारी चीजें टीचर्स।
सॉरी टू इंटरप्ट, सफिशिएंट। मैडम, आपने एक कहा अपने किड्स लर्निंग के लिए पेरेंट्स को थोड़ा इम्पोर्टेंस देना चाहिए, बट इंडिया इज सच अ वास्ट कंट्री एंड देयर आर पेरेंट्स who are illiterates actually, but how do I'm talking about in general, not a town people or a metropolitan people and all, but where can parents can help the small children?
Yes sir, that is a major problem, because many parents can't afford that.
Therefore, we have to suggest a method to teachers, the way which they can implement properly, so that every child can able to learn. And again, you have mentioned that somewhere Vedic maths tricks and concepts. I don't think for any foundation tricks will work. Only tricks will make you enjoy the things, that's all. You see the wonder of the things, how it happens. Though really foundations and all cannot be learned by tricks, most probably. And again, this is not the time to, go back to Vedic mathematics and then use those things, because already I don't think that numeracy is also required sometimes, I feel, because the logic is important, numeracy logic is important, development is important, but when the computers and all, so much advanced technology is there, I don't know how it will be useful. Anyhow, thank you so much. And any other questions are there, please, audience?
Excuse me, I have one question.
Please.
Yes, ma'am.
Please.
Is it possible practically implemented whatever you are suggesting? I mean a class of 40 students or 50 students where diverted group is there, whether it is tried with that group to implement these action plan?
See, ma'am, this is very difficult to implement, but if we do the tests, we can shortlist some students who needs really the treatment and really needs the attention, and we can then find out now which students कौन से बच्चों को ज़्यादा ज़रूरत है हेल्प करने की, और ऐसा भी हम कर सकते हैं कि जिन बच्चों को आता है उनके साथ पेयर करके भी करा सकते हैं। हमको बस समझने की ज़रूरत है कौन से बच्चे को कौन सी जगह पे दिक्कतें हो रही है, वो अगर हम टाइम के समझने की कोशिश करें तो शायद वो हम थोड़ा सा तो इम्प्रूव कर ही सकते हैं।
मैम ऐसा नहीं लगता कि इम्प्लीमेंट करने में डिफिकल्टी है, तो पता कैसे चलेगा कि कौन से बच्चों को कौन सी नीड है?
जैसे हम जब क्वेश्चंस उनको देते हैं, कुछ भी हम उनका जो टेस्ट लेते हैं, कुछ लेते हैं, तो उनके जो आंसर शीट्स होते हैं उनको अच्छे से ऑब्जर्व करने की जरूरत होती है कि कौन से बच्चे को कौन सी स्पेशल जगह पे, मतलब कोई होता है जैसे कि नंबर्स के साथ वर्ड्स को रिलेट नहीं कर पा रहा है, कोई होता है मल्टीप्लिकेशन की जगह पे गलती कर रहा है, तो हमको एग्जैक्टली उनके अगर जो फ्लॉज है
Once in a term you will be taking exam ना, every day after every period वो टेस्टिंग करना पॉसिबल नहीं होता ना, that is why
that would be possible। हम एक हफ्ते बाद या 10 दिन बाद ऐसा टाइम, या फिर महीने में 2 बार ऐसा कर सकते हैं। मैं वो जो बहुत बेटर तो नहीं हो पाएगा, पर अभी जैसा है उससे तो थोड़ा बेटर कर ही पाएंगे हम। इनिशिएटिव लेना स्टार्ट करेंगे तभी तो मैम हो पाएगी।
Okay, thank you so much.
Madam, if you don't mind, I would like to make one suggestion that when you are presenting slides, actually it would be much better if you reduce the text, because there was a lot of text, because then the people who are listening, they will be confused whether to read the text or listen to your presentation. So if you make it as a bullet wise, I'm not an expert, but still I felt, so I thought of telling you, sharing you, so that you will be benefited out of that. And the font size also can be slightly bigger, just for bringing it to your kind notice. Thank you, madam.
Okay, thank you so much.
Yeah, thank you so much. And next we'll pass on to the next topic. Dr. B.S. Sudhindra. Sir, you have given that figure out the logic with knowledge of current and previous. It looks beautiful. And maths phobia can be removed. Elimination of maths phobia is really good. We would like to listen to you from you that with a small illustration that may be better, because so much of ideas cannot be put in a 10 minutes time. So better is that be brief and clear, so that participants can be able to get benefit out of this. Thank you, sir. Please.
You are muted actually. You can unmute and speak. We are not listening now. Excuse me. You are not audible. You have to mute yourself. Unmute. It is unmuted, but still we are not able to hear anything.
Mic volume is too less.
Can you speak something? Excuse me, we are not able to hear you. One thing we will do, we will go to the next speaker and come back to you. By the time you can check your audio connections and other thing and make it ready. Sorry, we are not able to hear as of now. Dr. Lakshmi Sujata, we are not able to hear you. We will come back to you after the next speaker. By the time you can make it ready.
Next one is Sadhana Kulyalkar, Vidya Pratisthana English Medium School, Bridging NEP and Mathematics Education for English Medium Learners. Bridging the NEP and Mathematics Education for, does medium, no, I have my own doubt, does medium will affect the learning of mathematics at an early age? You know, we are interested in this. Please. Cut. What are the problems you tell us? How you can overcome those difficulties?
Yes, sir. Am I audible?
Yeah, sure. Yeah, you are audible.
Yes, you are audible. Please continue.
Yes, sir. Is my screen visible now?
Yes.
Okay, yes.
Sharing.
Yes, sir. Fine. Good evening, all. I am Mrs. Sadhana Kulyalkar, Indian maths teacher at Vidya Pratisthana English Medium School, Vidyanagari, Varanasi. Here in this project, we have tried to put what we have understood about the
give the supplementary sort of intervention for them. Because the major bottleneck for the tribal students here is that the residential schools were closed actually. Because they live in a very remote location and their own learning process, schooling process has been in the hostels, basically, the tribal hostels, which has provided all facilities there. So that was it here, but we have tried to do some classes in tribal languages, but those are not.
Regarding this pedagogical framework, like Dr. Biju has raised the question and Dr. Madhu has also was discussing about it. The basic thing is there is a area TPCK, you know that, technological pedagogical content knowledge. There is a use area and lots of work has been done in this area itself. And how this overlapping of technology and pedagogy, how this is affecting the content knowledge. If viewers are interested to look into details of these things, they can look into the this theoretical framework of TPCK. Lots of things are available on the net also, and how these are being implemented in the content. Suppose I am taking the content of the mathematics itself, and there is a well set pedagogy for the teachers that if they are teaching the fractions, if they are teaching suppose circles in their classroom, they are taking some pedagogical since long they are taking to those pedagogical steps for dealing the concept itself. But when you are introducing the technology, like you are introducing the GeoGebras there, so GeoGebras introducing of the technology is impacting the pedagogy also. The pedagogy is changed, the way of questioning is changed, the way of presentation is changed. So all these things can be if you are looking towards the detail of these things, you can go through the theoretical background of this TPCK and then try to implement in the content which you are looking which are in the practice. And the thing is that whatever the presentation we have seen from Mr. Anwarji, in Kerala they have taken care of all these things. The content, the existing pedagogy, and when the technology is coming, they have given the impact of the technology in the execution of the pedagogy also. That is the nice thing, and it should be replicated to everybody. It should be replicated to every state. and every state should learn the things should be consolidated in such manner. Any more question? Mr. Siddharth Kumar Singh has written that as you are telling that both online and offline classes are effective, from my perspective, I am an offline class. The teacher can interact and see the students' facial expressions to understand whether they are following or not. But how can this be accomplished in an online class? And the students have to sit for long hours. And can an online class be more effective overcoming these issues? So that is the thing. See, real classroom cannot be replaced by the technology. This is the first thing you should note it. Whatever the real practice, face-to-face teaching is there, blackboard teaching is there, and you are using technology in the real-time classroom, that cannot be replicated by any online classes. So, if you are in the online classes, your way of interaction, your way of assessment, everything has to be modified accordingly. There are ways, there are new technology available, there are new softwares available, there are applications are available, learning curves of the concepts are available. You have to go through those things, and accordingly you have to plan your assessment also, if you are looking the learning curves of the students itself. So I think there is no more question now. Dr. Madhu, you can take over take over the session and whatever the concluding.
Thank you, sir. Thank you for this. Lot of interaction were there in this session, because digital divide is a very serious issue. Our students and many teachers are faced this one in a real situation. What is the difference between virtual classroom and real classroom? They are feeling actually, and I think in the beginning itself it is told in what happened in the recent period. All over the world they were thinking of it as an interim arrangement, but it am I audible now?
You are audible. You are audible.
So all the world has faced this issue, and education sector is affected with the pandemic in a very severe way. But now we are coming back from that one. But at the same time, it has some advantages also, like the states have developed their own videos, their NCRTs developed their own videos, and when earlier we are telling about the flipped classroom and other things, people were not ready to accept that one. But now this is the situation. People are ready to accept, and when we are teaching in classroom also, students are in such a way that they are even the small children, they will go to the YouTube or go to the other kite pictures or any whatever channels they are available. They will explore there and they will tell that already we have seen this class, or some discussions was happening in the classroom by what they have observed. So this was a very effective session, and there will be a lot of discussions will be following this one. So thank you, Anwar Sadat sir, for giving your valuable time. Even though sir told 20 minutes presentation, it was a bit of interaction. It almost 1 o'clock is almost nearing 1 o'clock. So thank you, sir, for spending valuable time with us. Also, I would like to thank our chairperson, Chaurasya sir also. Thank you, sir, for chairing this session. And all the participants also, I thank for their time being, and we will break for lunch. And next afternoon session will be paper presentations. And paper presentations links have been shared in the chat box. So kindly join on time. We will be beginning little early, around 1:30 we will begin the sessions, paper presentations. So kindly be ready for that one. So there are 3 parallel sessions are going on. One is in the Cisco only, that is 2.1 will be here, Cisco, same link. 2.2 will be Google Meet, 2.3 is also in Google Meet. So we will hope all of you can join that time. Thank you, and there is a feedback session is there. Kindly fill the feedback session for this session feedback form. We will take it for your attendance also. Thank you once again everyone. Thank you, sir.
Thank you. Thank you.